then, and is that coming through okay for everybody? Is that good? Yep, great, okay. Well, good. Welcome everybody this morning for those of you who are in New Zealand, and this evening for those of you who are in Europe and other parts of the world. This is the workshop on empathic computing for IEEE VR. And I wanted first of all to introduce myself. I'm Mark Billinghurst from the University of South Australia and also the University of Auckland. And I'm direct the Empathic Computing Lab, both those universities. I'm very happy to be helping to organise the conference today. Saying it's hard to hear me. I'm sorry, Pablo. Hopefully everybody else can hear me okay. This is as loud as it gets. Arindam, do you want to introduce yourself as well?
Yeah, sure. Hi, I'm Arindam. I'm an honorary lecturer at the University of Queensland. Yeah, and I used to lead an empathic computing and empathic extended lab there. Yeah, I'm quite looking forward to working with you on this workshop. Thank you.
And Janet?
Yeah, hi, I'm Janet Johnson. I'm a PhD candidate at University of California in San Diego. Most of my work is around collaboration systems and how you ensure people communicate well across distances. And yeah, I'm looking forward to all of our discussions today.
Thanks, Janet. So, and welcome to everybody who's here. Hopefully over the course of the next few hours, we'll get a chance to get to know you a bit better. So first of all, I want to talk about the workshop goals. We really have three goals: is to present important topics in empathic computing and collaborative AR and VR related research, then to identify areas for future research, and also hopefully to grow the community of researchers interested in those topics as well. So to set the context, I wanted to talk just briefly about empathic computing, and then I will turn the time over to Anatole, who's our keynote speaker, and we'll take things from there. So first of all, empathic computing. So as humans, we know how important it is to be able to connect to other people and to communicate with them. In fact, Paulo Freire, who is Paulo Freire, who's a philosopher and educationalist from Brazil, said that only through communication can human life hold meaning. So that's a really powerful statement. And of course, over thousands of years, we've developed a wide range of different communication technologies to help us connect with one another. And in my opinion, there's three trends happening right now in the communication space. Oh, my slide just disappeared. Sorry. The first is a trend towards experience capture. So we're moving from seeing each other as faces on screens to strapping cameras to our bodies, or 3D scanners, and being able to capture our surroundings and share our surroundings. And we're seeing more and more examples of people live streaming, what they're looking at, or live streaming 360 views to try and immerse other people in those views. So capturing our experiences. The second is technology for more natural collaboration, and particularly faster network bandwidths, but other technology as well. So of course, 50 years ago, we had the telephone and then the mobile phone, and then now, my apartment here in Auckland has a gigabit fiber connection, so I can stream high definition content and video conferencing and even avatars and social VR environments into my home. So you can see people now as 3D characters and volumetric video. And then the third important trend is a trend towards implicit understanding. This means that now we're building systems that can recognize our behavior and emotion. So, you've got camera-based systems that can look at our faces and try and understand how we're feeling from that. We've got systems that recognize how our body's moving. You can push a button on your mobile phone and talk to Siri, and Siri can recognize your emotion from your speech, or even things we wear on our head, EEG electrodes that can recognize our brain activity. So all of these things change how we interact with the computers, because rather than telling the computer what we want it to do, it's monitoring us and trying to respond in an intelligent way. So these are three very important trends that are impacting on how we collaborate. And at the heart of that is really this notion of empathic computing. So of course, we all know what empathy is. Alfred Adler famously said that empathy is seeing with the eyes of another, listening with the ears of another, and feeling with the heart of another. So with empathic computing, the goal is really to try and develop systems that allow us to share what we're seeing, hearing, and especially feeling with others. So it goes beyond video conferencing. It's just not seeing somebody else's face, but it's really trying to understand their environment, and see what they're seeing and hear what they're hearing in that environment, and also understand what they're feeling as well. So there are many pieces of technology that have to come together to make that happen. You have to have some technology for understanding, and this is really around emotion recognition and maybe using physiological sensors to understand your emotional and cognitive state. Technology around experiencing, which is capturing environments or drawing environments, maybe using virtual reality to immerse somebody in an environment, and then also technology around sharing, which is about creating communication links, sharing your emotional state or what you're seeing, and potentially using augmented reality, which lets you overlay virtual content onto your environment or somebody else's environment. So we'll touch on some of that today. I just want to give you one example of a system we developed in our lab that kind of encapsulates what empathic computing is about. And this is a system that we developed 5 years ago now called the empathy glasses. And it was to try and reproduce some of the implicit communication cues that we have in face-to-face conversation. So when we have face-to-face conversation, obviously you can see the other person's eyes, you can see their face expression, and you can get some important communication information from those non-verbal cues. But you lose that when you move to a video conference system, especially a system where you're looking at the workspace of the other person, not their face. So we combined 3 technologies together. It was eye tracking, an AR glasses, and a special glass frame called the Affective frame that could recognize your face expression. And so the goal was to be able to share those cues, those gaze and face expression cues with the remote person. And in particular, the task was for remote collaboration. So we had somebody wearing this camera, an eye tracking system on their head, and then live streaming their camera view to a remote person. And the remote person would then be able to see what they're seeing. But because we have eye tracking, we could also show where they're looking. So if you see in this picture on the right, you'll see this green square or green circle. The green circle is the remote person pointing on the live video, so they can send pointing cues back. But then a little bit above that is this red circle, and the red circle is the person's who's using the system, their eye gaze. And so that's really important because now we can know where the person's looking. And of course, in the real world, you always look at objects before you interact with them. So now we have this implicit cue for communication. And then also at the bottom, we had a heart rate monitor, so you can see the heart rate and also a simple representation of their face expression from the Affective glasses. So let me show a little video of this working. So you see here the person wearing the system on their head, and the goal was to try and assemble these blocks in the real world, make a little picture out of them. And as I said, they were live streaming the view back to a remote person who could then move their mouse around and tell them what to do. And then as you see, this red dot will follow their eye gaze. So the remote person now can see whether the person is paying attention or not. If the red dot is following the green dot, that means they're paying attention to what they're doing. And so that use it as a very important communication cue. And then when they finish, the face expression changes to a smile. And here's all the best technology they're wearing, mostly on the head, but the heart rate sensor. And we have this special set of photo sensors that can measure the distance to your skin, and from that measure your face expression to about 95% accuracy. So that's a very simple example of an empathic computing system. It allows you to see what somebody else is seeing, to share non-verbal communication cues, and to some extent know what they're feeling. And we found that by sharing that pointing cue and that gaze cue, people felt that they were significantly more connected to the other person. Now, of course, we can go far beyond that, and there's a lot of different technology trends that are happening today, much better displays, ability to do real-time space capture, so you can scan your environment and share it in real time, capture and share your hands, very, very good eye tracking that's now being integrated into head-mount displays, and most excitingly, a lot more sensors built into the displays. So you can see on the bottom here a system from Neurable that was one of the first to integrate EEG sensing into head-mounted displays. Now, next year with OpenBCI and Project Galileo, they will also be building a head-mount display that has EEG sensors integrated also with a range of physiological sensors like EMG and heart rate and so forth. And with the HP Omnicept, you can buy a VR headset with the heart rate sensing in it already. So all these things will combine together to enable us to explore the ability or the experience of empathic teleexistence. And what this really means is that now you can collaborate by moving from being an observer to being a participant. You feel like you're really with the person in the same space as the person and can collaborate with them. The communication changes from explicit to implicit. So again, you know, you can recognize all the implicit communication cues, and you have this experiential collaboration, this feeling of doing things together. So I think will dramatically change how we collaborate in the future. Rather than just having Zoom calls and watching people talking and their slides, you feel like you're actually in the space with them having a conversation. So that's a kind of a very high level about what empathic computing is like, setting the context. And from this, there are many research questions, of course. So, you know, how can you create novel AR, VR experiences to enable this type of collaboration? What type of communication models should be developed? So when you start introducing new technology, that will impact on people's communication behavior, and we can develop communication models to model that impact. How can we use physiological sensors to recognize and share emotion and cognitive load, and how can that be used to enhance communication? You know, if you can recognize somebody else's emotional state, how should that be shared with you to improve your communication with them? And then also methods for capturing and sharing the physical world, you know, using real-time space capture or 360 video and reconstruction. So we won't touch on all those topics today, but some of them. So here's the workshop schedule. So we shortly have a keynote from Anatole Lecure, and then we have our first set of paper presentations. We'll have 3 papers from Kate Loveys, Guillermo Carbonell, and Linda Jerry, and then a second set of papers from Magdalena, Ilona, and Arindam. And then, between these, there'll be breaks between those sessions as well. And then we'll also have a group brainstorming session starting around 2:20 p.m. New Zealand time. And this time we'll discuss together what we think some of the important research questions and topics are, and potential solutions for how to do that research. And we'll have a wrap up at 4 o'clock. And I should also mention, if I go back to the beginning here, if you visit our the website for there, you'll also be able to visit the link to the Discord channel. So on the Discord channel, you can post questions and feedback to the speakers' talks, and engage in conversation there as well. Of course, you can also use the chat function on Zoom, but with Discord, it may be easier to maintain the context of those comments going forward. So that's the overall workshop outline. Let me now introduce Anatole. So Anatole, I think many of you will know him. He's very well known in the research community in VR. He's a senior researcher and head of the hybrid research team at INRIA in France. And he's done a lot of research on VR, on haptic interaction, 3D user interfaces, and brain-computer interfaces. He was awarded the INRIA French Academy of Science Young Researcher Prize in 2013, and then the IEEE VR VGTC Technical Achievement Award for VR AR in 2019, which is a very prestigious award from IEEE VR and VGTC. And today he's going to talk about exploring cerebral and bodily synergies in shared virtual environments. So I'll turn the time over to you. Let me stop sharing my screen here, Anatole, and hopefully you can start sharing your screen.
Okay, thank you very much for the introduction, Mark, and for inviting me, Arindam, Janet, and Mark to this workshop. It's a pleasure to be here. It's a bit later in France, I suppose, but probably not. I'm not maybe the one in the worst situation today. So thank you all for being here and attending to this workshop and presentation. I'll be really happy to interact with you and to discuss about this challenging topic of empathic computing. I used to make a confusion due to my French and my bad French. I used to say empathetic, but I think it's not the proper word, definitely. It's not empathetic, but it's empathic computing. And I'll be really happy to discuss and exchange with everybody after that. I have prepared a presentation to describe our activity in relation to this topic of empathic computing at INRIA Rennes, my lab in France. I'm going to share my screen to show you these slides. And you let me know if you see the presentation. Okay, let me know. Do you see the slides?
Yes, perfect.
Okay, and Mark or Janet or Arindam, how much time do I have already?
About 30 minutes will be good.
Okay, great.
But we have some time for Q&A afterwards, so yeah, we'll see how
Yes,
it goes.
let me know if I'm too long or if I speak too fast. And feel free also to intervene and to ask questions during the talk. I'll be checking the chat window, or you can also inform me if there are some specific questions or requests in the chat window. I'll be happy to adapt my speech and to answer to your questions about this. So the title of the presentation is Towards or Exploring Cerebral and Bodily Synergies in Shared Virtual Environments. I'm going to present a few works that we've been carried out in our lab at INRIA Rennes in Brittany. It's the western part of France. I hope you can see my mouse cursor. Yes. Do you see the mouse cursor? Yeah. So it's the west part of France. It's the Rennes city here. Like it's 3 hour, 4 hour by car from Paris in the west of France. So I'll be talking about the research activity of our group in Rennes. It's a group here of around 35 or 40 people working and dedicated to virtual reality and virtual reality technologies. We are lucky to have in our lab this great VR platform with lots of devices, interfaces, and platforms, VR platforms. We are more than 100 researchers actually working on VR in Rennes, split into 4 teams, 4 research teams, one being my group. For instance, we have an access to this great and huge cave system called Immersia, which is a 10-meter wide cave in which we have recently incorporated haptic feedback here. And actually, it's a bimanual or a multi-user haptic system because we have 2 force feedback devices like this one. So we can have multiple users. And so synergies and maybe empathy between people tested within this cave system augmented with haptics. So it's an incredible setup. And if you have a chance to visit our lab in the future, we'll be happy to make a demo of this quite impressive facility that we have in Rennes. So the research path in our group is dedicated to the design and application of VR technologies. We have been working on this topic for the past 30 years. And we do that with a close link with perception, psychology, neuroscience. It's one of the main sources of inspiration for the design of our technologies in our lab. And it's also a main criteria for evaluation. We like to collaborate with specialists from those fields. As Mark said, it's very important in this topic that we are addressing, empathic computing. We need to collaborate with researchers from these fields to better design our technologies. And actually, a secondary goal in our group is to exploit the technologies that we are building, that we are inventing, to better investigate human perception, human behavior. And we really like to use afterwards our technologies to gain knowledge about the human perception or the human behavior. So lots of our papers are dedicated to technologies, but also opening new paths also on the field of neuroscience or psychology. And also, as the name of our team indicates, we are interested by hybrid systems, which were mentioned by Mark earlier on, which really refer in our case to the combination of different technologies, mixing input-output devices in VR, but also AR, mixing visual displays with haptics, gaze tracking, and brain-computer interfaces which are devices that we have started to work on in beginning of the year 2000, in 2003, 2004, something like 20 years ago, we started to work on BCI and we never stopped. So I'm going to show some examples, for instance, of this kind of combinations. This is quite a good representative of the kind of work that we like to design in our group. It's a brain-based robot control in augmented reality. It was published 2 years ago in TVCG. And I think it was the first work which was combining a brain-computer interface with a Microsoft HoloLens headset. Actually, we really wanted to test the feasibility and the compatibility between a brain-computer interface and an EEG acquisition machine and the real-time use of AR headset like the HoloLens. And we wanted to test if it's feasible, if it's compatible. And actually the answer is yes. You can use both at the same time. For instance, here to control a robot, a mobile robot. And this robot is achieving a very simple and basic pass here. But this robot is controlled by directly by using brain activity and the notion of SSVP, steady state visual evoked potential. You need to focus your attention on those flickering targets, which are represented using augmented reality. Looking at this target here will enable to make the robot advance, at this one to turn right, this one to turn left. It's flickering at different frequencies, and actually the corresponding frequency can be extracted from your EEG activity at the back of your head at the level of the visual cortex. If you're interested by this kind of approach, you can check our paper, but it's a good example, I believe, of investigating this combination, this mixing of technologies here, augmented reality and brain-computer interface. Another very representative example of the work that we like to conduct in this line of research of connecting technologies together, it's this, I think it's also the first publication about haptics and BCI in 2012. Here we wanted to connect an EEG headset and the extraction of mental states of the user together with the real-time use of a haptic force feedback device. And in the context of assistance to gesture, in this case, we extract the mental workload of the user by means of the EEG headset, and we adapt a guidance system as provided by the haptic feedback, a guidance system directly to the mental workload level. So if you have a high mental workload, then we will automatically launch the guidance system. And if you have a low mental workload, meaning that you are succeeding in your task, we don't activate the guidance system. And the guidance system is actually a force, a repulsive force from the walls of the maze here that the user has to cross. So you slide on the wall, you are repulsed from the walls magnetically, because here the idea is to achieve the maze without touching the walls. So it's quite complex task in this right part, sorry, of the maze. And it's very easy in the left part of the maze. So we assume that you would have a high mental workload on those parts and a low mental workload here, and that we would need haptic assistance here. And this is basically what you see here in those figures here. We display the mental workload index, which was measured by the EEG. And you see that here the mental workload is red here. It's quite high in those parts. It's blue here, meaning that the mental workload index was pretty low. And this is actually the workload index measured during when the haptic systems could be activated, and this is the case when the haptic system was not activated. And I hope you notice that actually it's more reddish here and it's less reddish here. So we have reduced the mental workload when activating the guidance system here. Okay, if you're interested, you can check this this paper on published in Neurohaptics something like 10 years ago. And this is a more recent example where we use our technologies, VR as a paradigm and EEG as a measurement systems to investigate a bit more the cognitive processes related to immersion. Here, we wanted to investigate here the neurophysiology of embodiment, virtual embodiment, and agency in virtual environment. So here, our intention was to identify novel techniques to characterize agency towards virtual body in virtual environments. Here, imagine that you control an avatar, a virtual representation of yourself in a virtual environments, and we play with the motion of your avatar, meaning that progressively you are going to lose the control of your virtual body. So you move your virtual hand, and you are going to visualize your virtual hand in motion, which is following your movement. But at some point at some stage in the simulation, your virtual body will behave strangely. So you move a finger, but another finger is actually moving instead. So you have a crazy virtual finger, or you have a body which starts to not to answer to your intentions, to your real movements. And what we measure in the brain of our participants here, I skip all the details, and there are lots of stuff in this paper, but what was quite interesting here is that we could observe EEG patterns and electrophysiological patterns in the brain of the participants when they were experiencing a strange behavior of their body, when they were losing the control of their virtual body. And this brain pattern was actually exactly the same as the one which is observed in the brain of schizophrenic patients when they are experiencing an auditory hallucination, for instance, a sensory hallucination. So basically what we concluded here was that when you lose the tracking in VR, when for instance, when your virtual body is frozen with respect to your real movements, when your avatar behaves strangely, your brain reacts as if you were experiencing an hallucination, like a schizophrenic patient. So it can be seen as a little bit scary, but it's a nice collaboration with a psychologist and a cognitive science specialist, Camille Genet, who participated and who led this very teasing study. Okay, so now let's dig into this topic of cerebral and bodily synergies in shared virtual environments, how to promote this kind of synergy in virtual environments when there are multiple users. So first of all, I wanted to stress the importance, and Mark told a little bit about it before, the importance of building tools for the community, for the research community, and trying to develop software and hardware technologies which enable to design and to study those situations and to achieve and complete those situations. So first of all, of course, software aspects, open source software, which would enable the research community to be able to better access the states of the user, the mental state, the physiological states, the motions, the intentions, the actions of the users. And on this topic, we have participated to this effort. I can mention this OpenVibe software. It's I believe, one of the most used software in the field of brain-computer interface. It's an open source and free software. It has been developed by our team at INRIA in Rennes since 2005. It's been released in 2009. You see an example here of BCI-based video games called the Mind Shooter, inspired by Space Invader, which is delivered with this software, this open source software that you can download for free right now over the internet at openvibe.inria.fr. And actually, OpenVibe is quite a success today, and we really want to continue to support this effort because we believe it's very important for the research community to have an access to these kind of tools to develop the future technologies of BCI and to test those future technologies, for instance, with patients, for clinicians, and so on. Today, OpenVibe is used in a wide range of applications in a lots of labs all over the world. We are very happy to continue to support and to exchange with our users. You can, if you type OpenVibe on YouTube, you will see lots of videos of systems based on BCI, be it for artistic performance, robotic control here. Motor control studies or neuroscience studies. It's really exciting to see how these tools, once they are available, are get appropriated by a lot of different people for a lot of different purposes. So regarding the hardware, it's also quite important and interesting also to see that a lot of people and labs and companies are starting to also to launch some efforts to spread those technologies, those hybrid systems and systems which are enabling novel sensing of the user, especially at the level of HMDs, head-mounted displays, which are becoming more and more equipped with sensing systems. Mark talked about the OpenBCI here initiative with the Galea mixing of EEG headsets plus HMD is super promising, this kind of projects, and we are fully supporting them, especially with OpenVibe. And physiological HMDs are also becoming a bit trendy, mixing a lot of different physiological sensing directly into the HMD. So quite recently, we have tried also to assemble different kind of sensors into an HMD. I'm going to show you how we did. Actually, it was a collaboration with the BICOM Research Institute in France, and they were the main leader and pilot of this project, assembling this HMD. And we worked with them on the signal processing aspects and on the human-computer interaction aspect. So they proposed this nice integration of different measurement systems from accessing the cardiac activity of the user, the electrodermal activity of the user, the ocular activity of the user, and also the cerebral activity of the user by means of a FNIRS measurement system. So here is a picture of the electronic card, of the cardiac sensors, of the electrodermal sensors. Everything is assembled into a 3D printed case, which is assembled at the level of the HMD here headset. Here you can see the FNIRS, also the little FNIRS measurement system here at the level of the front of the head. And the cardiac sensors is here clipped at the level of the ears, and the electrodermal sensor is embedded inside the HMD. And in the end, we have, for instance, demonstrated the use of this physiological HMD, assembling all these components. Here, in this case, we didn't use the FNIRS, the cerebral measurement systems. So we focused on the EDA and the electrodermal and the heart rate mainly, and also the ocular measurement system which was embedded in the HMD. And here we illustrated this in the measurements of mental workload again, but not with cerebral measurements, as I said. And to illustrate this, we considered the use case of a flight simulation, and it was a training simulator for the user. And the training simulator of this flight simulator was proposing different levels of difficulty for the task of the flight simulation by adding progressively a secondary and sometimes even a third task to achieve for the pilot, in addition to the piloting task. Here, controlling the fuel and also answering to some vocal commands and vocal order to change the radio, for instance, tuning. So it could be like extremely demanding in terms of mental workload, and also in some cases it was very low demanding. And we use this battery of sensors, and we had some kind of ground truth. This ground truth was the subjective mental workload as expressed by the user during a simulation. So I think it was every minute or every 30 seconds, the user had to record his or her mental workload on a Likert scale from 1 to 5, which is called the ISA value in the mental workload community. So every 30 seconds, the user had to press on this scale, to select on this scale the level of mental workload, the subjective level of mental workload from 1 to 5. And what is interesting here is that offline, we did a tenfold cross-validation to check if by using our physiological measurements, we could classify correctly the mental workload. Here we assembled the 4 and 5 answers. So we had 4 levels of mental workload, and the recognition rate was quite surprisingly good. The final performance was around, the final accuracy was around 65%, although it was a 4-class classification system. So we were quite impressed by the quality of the classification we could get by the physiological measurements. Of course, it's not 100%, and there are lots of room for improvements. So in the end, we could rather successively after that propose this real-time mental workload estimation using our approach. And we have this simulation here where you see in real time the electrodermal, the ocular and heart rate measurements, and here the estimation of the mental workload by the systems and the selection of the highest probability of mental workload of the user on a 1 to 4 mental workload level. So if you're interested by this work, it was published. It was published 2 years ago in ISMAR. And if you are interested, by the way, on this topic of cognitive virtual reality, or affective and cognitive virtual reality, recently we published a survey on affective and cognitive virtual reality in IEEE TVCG. And here you can find a nice description of previous works and related works on this topic of affective and cognitive VR, which we define in the paper, especially for works which are dedicated to the induction of affective and cognitive states in VR, to the recognition of affective and cognitive states, especially using, for instance, machine learning techniques in VR, and also, quite importantly, the exploitation of affective and cognitive states in virtual reality. So if interested, you can check this TVCG paper from 2021. Right, so let's now, after talking about the tools and the measurement systems, which are quite important, I think, in this community, let's see how to reach some kind of cerebral synergy in virtual environments or shared systems. And to do so, I'm going to take one example that we built nearly 10 years ago, actually. It's the brain arena system. At this time, it was one of the first multi-user BCI, multi-user brain-computer interface video games. Here, our intention was to connect 2 brains with the same video games. It was a very simple video game. I'm going to explain in a minute. And the idea was to have 2 people competing or collaborating together by means of brain-computer interface. So the system itself was quite challenging based on our open source software, OpenVime. So we had 2 users connected with EEG headset to a single video games, and they could test it either in solo mode, like only playing one user at a time, or 2 people at the same time. Here is the video of the game. So it was a very basic soccer or football video game. You had to score goals to the right or to the left. And to do so, you have to imagine a left hand movement or right hand movement. So activating your motor cortex, your left motor cortex or right motor cortex. So that's the reason why you have here electrodes at the top left or right of the head to record this motor cortex activity. And then to identify if the user is generating a proper left or right hand imagination. And when it works well, so you send the ball to the left or to the right here, the instruction is provided by this red arrow. So this is the solo mode, a single user with whose EEG signal are extracted and then processed. Here you see the pipeline on the top. Then there is an EEG classification step to define if it's a left or right hand imagination. And after the decision making, this decision of the classifier is sent to the interaction technique, which is sending left or right the ball, which is displayed on screen. This is the feedback to the user, which is after that exploited to learn progressively to control this motor cortex region activity. And more interestingly, this is the video of the collaborative mode. So here you have the two people connected to the same video game, and they receive the instruction of going both to the left or to the right together. And you see that it's a quite complex feedback at the center. These two green bars represent the activity of user one or user two as extracted by individual classifiers. So the classification of EEG of user one is displayed here green, and it goes progressively right and left. And the blue bar is the joint decision, so the average of the two classification results. And the ball here, it's a successful trial. And even more interestingly, we had this comparison with the competition mode. So here, the two brains are actually fighting one against the other. It's a mental duel. It's a mental confrontation. So you have to think louder or think stronger than the other user. So the user one here is receiving the instruction to think about the left hand, while the other has the other instruction. And the person who succeeds in providing the more regularly the appropriate imagination of movement is winning the trial. So at the end of the trial, you have a winner and a loser. The winner being the one who has been able to perform the more stable and longer activity and brain activity. Okay, what's interesting in our results is that if you propose this kind of combination of brain, in experiment one, we tested this combination, this collaboration of brain. We compare it with a solo mode in which you are alone and performing the task alone. What is interesting here is that, of course, in terms of user experience, it's more fun, it's more motivating to achieve this task with another person, with another user. And what's interesting is that the average classification accuracy is overall the same, but for the people who were the most successful, half of the people, like 10 people out of 20, when you enter into the collaboration mode, your performance, the classification accuracy is significantly better. So that's kind of surprising, but actually it's exactly the same task. It's exactly the same brain activity which is extracted, but the simple fact of being with another person is significantly increase your capacity to produce this EEG activity. And we conducted the second experiment with 8 people only. And this time we even added this competition Here we didn't have a lot of users, but we observe a similar tendency with an increase of the competition or collaboration versus the solo mode. And it was a bit unclear how collaboration or competition would lead to different results. Okay, so this was a very inspiring setup for us. We thought of different variations of multi-user BCI schemes in the future, thinking of different ways of combining the EEG of the different users, of the two users, either at the level of the signal, so we could merge all the EEG data together before the classification to have even more data to classify, or after the classification step. That's what basically you can do to make a decision based on different individual classification results, or after, once you have taken an individual decision, you can then, considering a different decision-making rules, you could then decide afterwards based on all the individual decisions, or at the level of the interaction techniques. You can also take as input differently the different decisions and take a different decision. So there are different paradigms for exploiting the situation of mixing brain data and multiple user equipped with BCI that could be explored in the future, and it's quite an exciting topic. It's sometimes referred in the BCI community under the term hyperscanning, scanning the brain activity of multiple users, and sometimes mixed with other physiological signals. So it's quite a very active topic now in the BCI community, and also in the physiological computing community. Let's talk a bit about the 5 minutes left. Okay, sorry, Mark. Thank you. And I even don't know when did you send me this message? Was it like 10 minutes ago?
No, just now. So it's okay.
Okay.
Yeah.
So about bodily synergy, I'm going to finish in 5 minutes. First of all, after the brain, the body in shared environments, we have this nice situation now where we can study virtual embodiment and relationship and connection with avatars in virtuality. It's a very hot topic, especially in the context of shared virtual environments. I think it's opening a lot of new paths. This is one of the first paper we published in this topic, where we compare the situation of being alone in front of a mirror, and two users at the same time, and testing this these different situations on the sense of embodiment, on the body ownership, agency, self-location that you could feel when you have an avatar. And interestingly, we noticed that the fact of being two, for instance, was influential on the sense of embodiment, for instance, when compared to the mirror situation. And people generally don't like the mirror, and it's impairing a bit their sense of embodiment. And the fact of being two is considerably increasing their motivation, this whack-a-mole task, and also starting to show tendencies in the sense of embodiment. But more interestingly, and more recently, we explored a very teasing situation of co-embodiment in which the oh, I hope you can see the video. Let me check again. Let's see. Seems that I have some issues with my computer, right? Can you hear me, Mark?
Yes, I can hear you just fine.
Yeah, and but the video is not playing, right?
No.
Okay, so let me talk about virtual co-embodiment. If you hear me right, here the idea was to investigate a very teasing and unusual situation of here being two people embodied in the same virtual avatar, in the same body. So two people in the same virtual body. I hope I'm going to be able to play the video. Let me check if I can Start again. Yeah. Okay. So you see, one user is turning the hands. One user is having this up and down motion with the arms, and the resulting avatar with the weight of 50-50 for each motion is having this intermediary motion at the middle of the video. And we could compare this situation in different tasks. A free task where you have to click on a target, two users being in the same body and controlling half of the movements or a different weight of the movements. I'll come back to this right after. Or you have to highlight a specific to touch a specific target. Here it's a free movement target here, or you have to follow a trajectory. Two people being again embedded in the same avatar. And people had to judge and estimate their feeling of control, which is strongly related to the sense of agency, the feeling of controlling the avatar. We were asking the question, how much did you feel in control during this trial? And what is interesting here is that we tested different balance of weight between the two users, one user having sometimes 100% of the motion, the other one having only 0%, and sometimes 75%, 50, 25, and 0. What is interesting is that the feeling of control of the participants were quite well estimated, but interestingly, they had a tendency to overestimate their agency, their feeling of control, the fact that they were controlling the avatar in the case where they had zero control of it, meaning that whatever they would do, the avatar would not consider as input their motion, but would extract only the motion of the other user. And especially when during the trajectory mode, or the target mode, they were overestimating strongly their level of control of the avatar. So what is interesting here is that it's a new concept of mixing body movements in VR for a co-embodiment to the same avatar. It can elicit a strong sense of agency that's and people are quite well accepting this very strange situation of being embedded in the same avatar as the other user. And we believe that right now it's a very interesting scheme for future application, especially training scenarios where the trainer and the trainee could share the same avatar, and the trainer, for instance, could sometimes take the control of the avatar to show to the trainee how to perform a task, for instance. And also for rehabilitation, it could be interesting. Okay, I hope I was not too long. If you have some questions, reactions, or future questions by emails, I'll be happy to answer them and to exchange with you. Thank you very much for your attention.
Thank you so much for your presentation. So there's a couple of questions. One in the Discord, Pablo asks if he's asked questions about the last video you showed, the co-control over avatar. He said he wonders if these results are affected by the co-presence of subjects. Will the results be the same when subjects are in different physical spaces? So I'm not sure if you want to talk about that at all.
Okay, let me rephrase it a bit because I had some auditory issues. So the question is about during the co-embodiment, do we think that there would be an influence of the people being in the same physical room or in remote room in the real
yes, he was asking
setup?
about the co-presence of the subjects. Okay. That's right, yeah.
Okay, that's a good question. If I remember well, I think that our participants were in the same room, but they had the instruction of not speaking and not making, and they were not hearing actually the activity of the other. And we didn't test the remote situation. So it could be an interesting hypothesis to test. I believe that the people still were not really aware about where the user was. So it was a bit dubious that they were considering that it was that they were really sharing, or they were in close proximity with the other person in the real setup. So I think it's not something that was probably in the consideration of the user, but clearly we didn't test it. I don't think there is a strong. My conviction would be that my first intuition would be that there would be no effect, but it's a complete intuition, and we would really need to test it. So if Pablo, you want to test it, feel free. It's a very intriguing situation, and it's a really teasing experiment that need to be replicated.
And then Rory has a question.
Thank you, Anton.
Thanks. Rory has a question. What specific rehab or training problems in the real world do you think you could help solve by this virtual co-embodiment?
It's a good question too. I think you should ask Rebecca. Rebecca Fribourg was the first author of this paper, and she was quite interested in those rehabilitation aspects. So you could ask her. I wouldn't want to say something stupid here, but I was more thinking about in the training scenario, like the fact that a trainer could show how to perform a gesture, a specific gesture or a specific procedure to the trainee. So is it something which is meaningful in a rehabilitation context, like somebody would show you what you should do with your body and what kind of, for instance, motion amplitude you should reach? We should really ask a clinician about it. What's the potential about it? So I don't want to say something stupid here. Sorry if I'm not answering fully to this question. It's a good one.
Okay, and then there's one last question. I mean, there'll be some other things coming up in chat, Anatol, so maybe you can check on the Discord channel as well.
Okay, I'll try to make my way there. I didn't find the way yet.
Yeah. So there's Sandro asked a question. He says, do you follow us in terms of integrating the input from the hardware? Do you follow a systematic or reasonable approach of integrating the sensors into each other, or is it more on application level basis or an experimental basis? I guess that's talking about what type of software framework you use to integrate the input from the different hardware.
Yeah, it's a very good question, and we do both actually. For some aspects and some integration aspects, we clearly have we try to have a software platform for integrating as much as we can, especially for our work on avatars and virtual embodiments. So we have our own proprietary software for assembling all our work and activity on virtual embodiment. And on the physiological computing aspects, we mainly integrate a lot of our research activity on EEG in OpenVibe, our open source software, and all our research activity is made with OpenVibe, and we try to integrate as much as possible in OpenVibe. For the physiological computing aspects, the work I've presented were done with another partner, Become, so they have their own platform and proprietary platform. In our case, we don't have much on physiological computing apart from EEG, and it's quite complex. So definitely we would need open source tools for physiological computing, which would be usable easily in VR.
Great, thank you. So let's thank Anatol again, and there's some other questions that popped up in the chat here, Anatol. I hope you can see the chat questions and also in the Discord, so feel free to answer those. But we need to go on to the paper presentation. So very nice presentation, and of course you'll be around during the rest of IEEE VR, so people can ask you.
Yeah, I'm really sorry I won't be able to attend the entire workshop today. It's a bit late in France and I have family constraints, but I was very happy to be here, and I wish you all the best for the workshop. I'll stay some minutes now to answer to the question on the chat, and I'll try to find a way to go on Discord. Thank you very much for your questions. It was
great. So
it was
I'll
nice.
turn the time over now to Arindam, and he's going to take us through the next set of papers from the various submitted presentations. So over to you, Arindam.
Sure. Thanks, Mark, and thank you, Anatol, for the nice talk. So we'll now move on to our first set of paper presentations. So the first paper will be presented by Kay. Sorry, I'm just. So I have made you a co-host, Kay. If you want to share your screen.
Oh, great. Yeah, I'll just set that up now. Just going to my slideshow, sorry.
Yes, we can share your desktop, but not the slides fully.
Is that working?
Yes. Okay, great. Thank you. So Kate is going to present about exploring empathy with digital humans. So over to you, Kate.
Great, awesome. Okay.
Hello, my name is Jane and I am a digital human. Today we're going to talk about empathy with digital humans. I hope you enjoy the presentation.
So hi everyone, my name is Kate Lovies. I'm a postdoctoral research associate working at Soul Machines and also with the University of Auckland. My PhD was in health psychology, so I come to this workshop as a research psychologist who works quite closely with engineers to build and evaluate technologies that bridge our two disciplines. So today I'm going to be presenting the research agenda for a project that evaluates and builds upon the autonomous empathy system of a digital human. And in presenting our research agenda today, we'd be quite interested to hear people's feedback on our proposed approach and our methodology and our directions for our research.
Hello.
So firstly, what are digital humans? So digital humans are a new type of embodied conversational agent, or ECA. For reference, ECAs are computer-generated entities that include a dialogue system and an animated face or a body. So digital humans are a more sophisticated type of ECA that are autonomously animated models of real people in terms of their appearance and quite often in terms of their cognitive architecture. And they use real-time neural networks to classify people's emotional states and inform their social responses to people. And given their virtual form, digital humans can be delivered over websites as well as through alternative delivery environments such as an augmented or virtual reality, and potentially one day if it comes about the metaverse. So digital humans are scalable, yet are capable of forming relationships with people. So they have many possible applications in areas such as healthcare or education, and maybe even serving as companions to people. However, for digital humans to be engaging and effective in these applications, it's really important that they're capable of empathetic interactions. So empathy refers to the ability to perceive and share the emotions of other people, as you're well aware. So according to the perception action model, empathetic responses can be affective, cognitive, or somatic. So affective empathy refers to the emotions we feel in response to another person's emotions. So for example, perhaps I feel sad after seeing my friend get bullied. Cognitive empathy is more our ability to identify the emotions of other people. So for example, perhaps right now I can tell that my friend is sad. And somatic empathy is when we experience physiological responses to other people's emotions. So for example, perhaps my heart races when I see my friend in distress. And when empathy is delivered appropriately, it's been shown to reduce emotional and physiological distress in the receiver, and it's been shown to improve relationship quality between the giver and receiver. Hence, it's quite an important social skill for digital humans to master. So when looking at the research to date on empathy and ECAs and digital humans, ECAs have only really relatively recently started to be programmed with the capabilities to detect the emotional states of users. Sometimes this is achieved through a multimodal system that's looking to detect user emotions from several data streams, for example, through speech and gesture recognition. This approach is more complex and resource intensive, but may result in more accurate predictions. In other cases, the systems function more simplistically and focus on detecting emotional signals from a singular data stream. However, this approach can increase the chance of error, given that some emotional signals can actually be quite ambiguous without contextual or convergent information. And recent advances have enabled the development of autonomous multimodal emotion detection systems that digital humans can use to inform their empathetic interactions in real time. Although the research field is somewhat developmental, some promising results have been found to date, particularly in terms of virtual characters with autonomous empathy systems being rated as equally appropriate and accurate to when responses were controlled by a human in the loop. But more research is needed to understand what are the most effective techniques for an automated multimodal empathy system in digital humans, as well as how digital humans can best express their empathy to users as part of this automated system. And research to date shows the importance of many behaviours for improving empathy perceptions towards agents. Some examples are things like forward leans or head nods, particular emotion expressions in the face. And in addition, it's not clear whether receiving automated empathy from a digital human improves psychological and physiological responses in people in a similar manner to human empathy, However, it seems possible, given in the adjacent literature of social robotics, empathy from a robot's been shown to have these effects on people's outcomes. And then when we look at the literature on empathy towards ECAs, evidence has been found to suggest that people can experience cognitive and affective empathy towards embodied agents and robots. And there's also some evidence for somatic empathy, but more research is needed to explore this, including with a broader range of physiological outcomes. And more literature could also look at empathetic interactions with a digital human in augmented and virtual reality environments. It's possible that augmented reality or virtual reality may amplify empathetic responses to digital humans because of the increased social pressure that they may have in these environments. Sorry, social presence, I should say, not pressure. So with this in mind, our research project aims to investigate whether people perceive the digital human as empathetic towards others. We're also aiming to evaluate whether people perceive the digital human as empathetic towards themselves. And we're also interested to investigate whether people feel empathy towards a digital human that's giving off emotional cues. So to address the research aims, we've developed a research agenda consisting of 5 experimental studies. And note that between each study, we will use the results from the previous experiment to improve the empathy system for the next study. Each experimental study will recruit 88 participants based on the results of the power calculation, and participants will be a community sample of adults aged 16 years or older with English fluency. So first we will conduct a video study, which will be based online, that aims to provide a preliminary evaluation of the empathy system's current performance compared to a neutral control. So participants will be randomly allocated to watch 2 videos of either an empathic or a neutral digital human while it interacts with an actor. And in one video, the digital human reads emotional stories while the actor responds. And in the other video, the actor reads emotional stories while the digital human responds. And these emotional stories are adapted from previous research by Wyden and Russell. So self-report measures will be administered at baseline and after the videos. And at baseline, we will assess demographics and trait empathy. And then after the videos, we will assess perceived empathy and the appropriateness of the responses, cognitive and affective empathy, relatability, and perceived match between the digital human's expressions and the story content. So then we will conduct a conversational study, which uses the same design as the video study, except it will be conducted in person in a laboratory at the University of Auckland. And in this study, participants will directly interact with the digital human to read out and respond to these same emotional scenarios from the video study. And this study will use the same eligibility criteria as the video study, but participants will be required to also like acting. And this is really to increase the chance that participants will be willing and able to act these emotional scenarios and trigger the empathy system. And in this experiment, we will also collect audiovisual data, which 5 research assistants will use to assess the emotional acting ability of the participants. And this will enable us to analyze the performance of the system by how emotionally expressive the participants actually were. So overall, this study allows us to evaluate the performance of the system during direct interaction with users. And then the third study that we plan to conduct is a physiological study, and this will have the same design as the conversational study, but we'll also collect data to assess somatic empathy responses. So this will include heart rate, skin conductance, EEG, and facial EMG data. And then we will conduct an augmented reality study to investigate whether the effects of digital human empathy are amplified in an immersive interaction environment. And this study will use the same design as the physiological study. However, the digital humans presented in an augmented reality environment. And participants will use a HoloLens 2 headset in a controlled environment after training and orientation to the headset. And then lastly, we will conduct a cultural study to test our process of tailoring the empathy system and to evaluate whether cultural tailoring improves system performance. Although the earlier phases of the research collect participant ethnicity data as a variable that we can consider in our analyses, this phase specifically explores culture as the main variable of interest. And in this study, we will vary the emotional behavior of the digital human based on the cultural norms of the cultures from which we will recruit participants. And at the moment, we're considering recruiting from cultures based in New Zealand, potentially the United States, Japan, and a to be determined European country. And the emotional models will be informed by a thorough and prolonged cultural consultation process with experts from these cultures prior to research design and commencing our model adaptation processes. And we expect to refine our methodology for this experiment during the consultation, but we anticipate that it could potentially have a similar methodology to the conversational study. Although international participants will probably need to take part online, but we're still figuring out those details. So in terms of our progress to date, we've received IRB approval from our University Ethics Committee for studies 1 to 4, because we're still designing the cultural study. We've also started on the development of our digital human for the video study, and we're preparing the protocols of our studies for registration in the Open Science Framework registries. And then once our digital human is ready, we'll be able to start recruitment for our video study. And then in terms of the cultural study, we're still determining our methods for cultural consultation. And our next steps will be hiring experts to consult for us and then designing the IRB application. So some discussion points have arisen during our research design process that may be of relevance or interest to people at this workshop. So these are some of the findings around individual and group differences in empathy responses from the psychology literature. And we've taken these into account when designing our studies, as we expect that they could affect our results. So these are firstly that people tend to show more empathy towards others that they perceive as similar to themselves, either demographically or psychologically or by some other characteristic. So we're needing to take this into account when we're thinking about the design of our digital human and its match to our participants. Secondly, there are differences in cultural norms for emotional expression that could affect how a digital human should interpret a user's emotional signals, as well as how a digital human's empathy responses are perceived by users. And digital humans that violate the user's cultural norms for emotional expression may be less effective with their empathy. And the literature around cultural variation and emotional expression can provide some guidance for designing the emotional detection models and digital human behaviors for different cultural contexts. And lastly, people with high trait empathy may be more empathetic towards digital humans irrespective of their design. And conversely, people with very low trait empathy may show very little empathy, even when it would be warranted from the average person. So to account for this, we measure trait empathy in the baseline assessments for our studies so that we can control for this in our analyses. So these are all findings in the literature that we felt could influence our results in some way. So that's the end of my talk. Thank you very much for listening, and I look forward to your questions at the end. Also, just with coming from a psychology background, I'll say that if there's any particular technical questions I'm unable to answer, I'm happy to take these questions to some of our engineering team and get back to you as well. Alrighty, thanks everyone.
Thank you, Kate. So I forgot to mention in the beginning of the talks that we'll have all the questions towards the after all 3 talks are done for this block. So yeah, thank you again. So let's invite Guillermo for his talk on conceptual design of emotional and pain expressions of a virtual patient in a virtual reality training for paramedics. Over to you, Guillermo.
Yeah, thank you. Can I already share my screen, or you have to?
Yes, you should be able to share your screen. No, you can share your screen.
Okay, I guess I can share the whole screen only, which landed me somewhere else. Now, this should be it. So, hello everyone, and yeah, I'm really glad to be here presenting from Germany at Friday night. I will present our paper titled Conceptual Design of Emotional and Pain Expressions of a Virtual Patient in a Virtual Reality Training for Paramedics. Before we start, I would like to show you a broader perspective about this paper. This paper was done under the project Vitavin, and the main goal of this project is to develop an interdisciplinary mixed reality training for paramedics and emergency training nurses. We take a simulator mannequin and integrate it into a virtual medical scenario in which students can train by treating a patient with burn injuries. The project is relatively large, but on this particular paper, we focus on social aspects of VR, namely how we designed emotional interactions with the virtual patient for this MR training. Now, why is it important to offer an emotional interaction with the patient? Well, in our MR setting, our virtual patient does not process or generate speech. Paramedics and nurses are used to train with mannequins and with actors, and in both cases, they talk to the patient. With the mannequin, the trainer will give students the answer that they ask the mannequin patient, and in many cases even simulate the pain. Same thing with actors. However, when using VR, the fact that the trainer or a fellow student talks to you from the physical environment generates a huge disruption on immersion. And we would like to avoid that. And one way to do it is to provide the patient with nonverbal cues that students can use to decide how to proceed without having to ask. So how have other researchers and developers solved the problem of giving emotions to virtual agents and especially to virtual patients? There is a very interesting review on this topic, and I will not go into details with this. And I must say that I'm very glad that the next presentation is a review on training empathic skills. Perhaps we will learn more about this topic with the next presentation. But for now, I can tell you that there are many ways to give agents emotions, but we can categorize them according to this paper into virtual solutions, which are quite flexible, as we see, hybrid solutions, and physical solutions, which are in general quite rigid to develop or design. In many of these creations, designers and developers have used the facial action coding system, FACS of Ekman, which gives a great guide on which muscles to tweak to generate a certain emotion. And we guided our design on the FACS as well. Now let's take a closer look on the papers that did a similar work compared to ours. Cotranza and Locke already in 2008 developed a MR scenario where patients, well, in this case, participants, touched the virtual patient as frequently and as many times when compared to the interaction with actor patients. The virtual patient in this MR scenario was programmed to show pain reactions verbally by saying, for example, ouch or it hurts, and visually by showing pain in her facial pain expression. The participants reacted accordingly by reporting higher empathy with patients who show an appropriate emotional response. And precisely the emotional response of the patient is a relevant feature in any medical training simulation, since medical staff need to interpret signs about the patient's state by understanding their emotional reactions and pain level in order to act accordingly. Bolonte and colleagues observed in the galvanic reaction and the questionnaire responses of the participants when interacting with multiple virtual agents that presented different emotional states. And they found a positive emotional state in virtual agents increases the participants' number and durations of interactions. This evidence suggests that it is important to design virtual agents with realistic emotional reactions in a medical emergency setting in order to observe an empathic reaction and increased engagement in training. So we know that there are many technical approaches to give emotions to virtual patients, and virtual solutions in this case allow for more flexibility. We also found in the literature that users interact more and show higher empathic response to virtual agents that show emotions. And based on our motivations and on the current state of the arts, we need to ask the following questions to approach our design phase. Which emotions are relevant? How to adapt the emotions to our specific case with the burnt patient? How and when should the emotions be displayed? How do participants react to the emotions of the virtual patient? So let's try to answer some of these questions. The project started with long workshop sessions to identify needs and requirements of end users, but for this specific case, we will focus on the pre-study that we carried out with 4 experts, 2 trainers of vocational study for paramedics, 1 trainer for advanced emergency nursing, and 1 medical education expert. With this focus group, we wanted to know how important are the emotional and pain expressions of patients during real emergency, how important it is to integrate accurate emotional and pain expressions into a VR training, and in which cases it is important to touch the patient to intensify the social interaction, for example, to comfort or to reassure the patient. We confirmed that emotions are an important information source when treating the patient, And when treating patients with burn injuries, fear and high levels of pain are quite common. Regarding the pain, the experts reported that patients are asked to rate their pain in a scale from 1 to 10, 10 being the highest pain. They consider that including emotional reactions is important as long as these fit the educational purposes, meaning that they are accurate and are displayed at the right moment. Finally, and more interesting perhaps for the MR topic, they said that touching patients is relevant to give them confidence in the treatment. And there is actually no medical algorithm that tells you when the pain is high, then check this and touch the cheek or then touch the forearm. No, this is more about the experience and about certain feeling that develops over the years with training. So after this conceptualization, after the pre-study, we needed to start designing the emotions. And we did so. We acquired a virtual head which allow us to rig and to tweak a lot of muscles and created pain expressions ranging from 1 to 10. And furthermore, we designed all the 3 relevant emotions for our training, which are fear, relief, and shame. We did an online study with 107 participants in which we mainly presented 3 tasks. The first one, observe these pain expressions that you see here, one after another in a pseudo-random order and rate them in a 4 points Likert scale with the questions, is this expression realistic? Is this expression credible? Second task, observe the 10 pain expressions all at once and arrange the pictures from the lowest to the highest pain. And finally, participants saw a 22-second video animation in which the virtual character transitioned between different emotions like neutral, strong pain, relief, fear, mild pain, and shame. And the task was to arrange these emotions according to the order that they observed on the video. Let's check some results. When analyzing the results of the first task, we observe a clear curve that we consider to be a learning or a habituation curve. Participants were probably undecided when rating the first pain expressions and scored both aspects on an average level. After the next pictures were shown, participants found the expressions more realistic and believable due to familiarization. This result can be interpreted twofold. The pseudo-random order is accountable for the learning curve that was observed, which obliges us to carefully interpret the results since we might not be testing a clean observation of the realism and credibility of the visual designs. However, on the other hand, the fact that the continuous presentation of these images has an impact on the participant's perception is a sign that the familiarization with these stimuli might increase the realistic perception in users, which could also increase immersion and involvement in VR. Both interpretations do not exclude one another. However, it would have been beneficial to completely randomize the order in which the pictures were presented. Unfortunately, we were not able to do so when making the survey, but this is proof of the importance of randomization in behavioral research. Still, very interesting results. We found that the pain expressions that we designed were arranged in the expected order, meaning that the pictures that we designed as pain level 1 or 2, for instance, were categorized so by 95 and 81% of participants. The categorization gets problematic between pain levels 5 to 8 because there are many similarities and it is quite hard to make such a specific differentiation. But still, the majority of participants backed up our design on every pain level. Finally, the task with the video did not work as well as expected. Participants could not accurately arrange the emotions in the order presented in the animation. And we believe that participants recognized the emotions correctly, but failed to report the right order. let me show you. So participants had the 6 emotion labels available, and they had to arrange them in the order presented on the video, like this. I will play this and hope that it flows nicely with you. So there was neutral, then strong pain, then relief, to fear. Then we go to mild pain, and then to shame at the end. I hope that you could see that clearly and as it flowed good on the screen, in your screen. Yeah, but in this case, perhaps it would have been helpful to label the emotions in the video. And by doing so, participants would have recognized exactly the section on the video they should pay special attention to. So, for example, by strong pain and neutral, there were many that said that it was neutral and strong pain. But by fear and mild pain, it was really quite hard, and many people just didn't get that right. But again, I think it was just more a thing of the task than the actual emotion that the agent was presenting. So after checking on these results, we decided to work on a conceptual design for our MR training. With our results, we interpret that our design of pain expressions represents accurate pain levels. Users will get used to the virtual characters and its nuances and perceive it as more realistic within short time. And also interactive animations need to be studied carefully. On this table, taken from the paper submitted to this workshop, we see the medical procedures that lead to a certain emotional reaction. For example, removing clothes could lead to fear, strong pain and shame, and a touch on the shoulder could cause relief, and a hopefully unintentional touch on the wound causes strong pain. Let's check a video on this. I don't know if you will be able to hear the audio feedback, but just so you know, the patient screams with high levels of pain, 8 to 10. So now the patient is screaming. I don't know if you hear the scream, but there is screaming going on here. You have relief. Fear when syringe approaches, and also fear when removing the clothes. So after checking the current state, let's see what we can do in the future. And this is mainly the final question that I posed some slides ago. How do participants react to the emotions of the virtual patients? And we already conducted an evaluation with the VR prototype with paramedic students, assessing variables such as usability, presence, and simulator sickness, and quite interesting for us, asking questions about the emotions they observed and the interaction with the patient. Unfortunately, I don't have preliminary results yet, so I invite you to follow us and to check upcoming publications. These are the references that I used for this presentation. A bit more extensive list is to find on the paper. And this work is part of the project Bitavin, which is financed by the German Federal Ministry of Education and Research. And I would like to thank and acknowledge the project partners and our research team for interactive reality experiences, IREX. I invite you to go check our website for more information. And last but not least, thank you very much for your attention, and thanks to the organizers for this workshop.
Right. Thank you so much, Guillermo. So we'll move on to our next presenter, is Linda. So Linda is going to talk about training empathic skills in virtual reality, a scoping review. So Linda, if you can please share your screen.
Yeah, no problem. All right. Can everybody see?
Yes, we can see it.
Okay, perfect. So yeah, I I'm just starting my PhD, so I started out doing this scoping review on empathic skills training, specifically in virtual reality. And I guess I'll start by just talking about general conceptual definition of empathy. So for the purposes of the scoping review, I divided empathy into 3 components. More traditionally, it's defined into cognitive and affective, and then the behavioral dimension is considered sort of a outcome of empathy. But for the purposes of focusing on design features and making them parallel with these constructs, I divided it into these 3 different components. So the first, cognitive empathy, involves these skills such as perspective taking, which is the ability to imaginatively project yourself in the shoes of another person. Mentalizing, which is related to theory of mind. Again, I'm coming from a psychology background, so you guys might not be so familiar with these terms, but I'm happy to answer questions and go into more depth afterwards. Essentially, mentalizing refers to the ability to understand what another person is thinking and feeling, and to understand things that they might know that you don't know, and vice versa. Self-other overlap and merging is the ability to include another person into your self-concept. Attitudes in empathy are specifically pertaining to positive and affirming attitudes towards a specific person or the group to which they belong, or negative attitudes and stigma or biases, prejudices also, you could say. And then there's also self-other distinction, which Jean Desady famously discerns as a feature of mature empathy. And so you have kind of both of these things going on at the same time, where you have self-other merging, but then you also have the ability to differentiate your own thinking and feeling from that of another person. So that's all within the cognitive domain. And within the affective domain, we have emotional resonance, which is something that sort of happens automatically within the brain and body of an empathizer. While observing another person, we start to have neural pathways that are sort of as though we were experiencing the suffering of another person firsthand. And then there's also personal distress, which is sort of resonating with the suffering of another person. And I guess the counterpart to that is empathic concern. And empathic concern is sort of the ability to care for another person, to exhibit concern and care, and to be focused on another person. And a key skill in this, therefore, is emotional self-regulation, the ability to regulate one's own emotional response to another person. And then behavioral empathy involves helping behaviors, advocacy, and communication. So these are some of the things that VR is kind of good at currently. We have a lot of simulations of perspective taking, where you see and hear from another person's point of view, traditionally called virtual embodiment. I'll go into this in a little bit more detail in a moment. And then also emotional resonance, because VR is so emotionally impactful. There are so many experiences just using 360-degree video that are highly impactful on people and influencing their emotional empathy more so than traditional media. And then for helping behavior, we also have a lot of simulations that are training people on how to more appropriately help someone in need, that are focusing on target groups of oppression. And I guess what my findings indicate from my initial scoping review is that these are some of the areas where we're lacking, or where VR could do a bit more to facilitate empathic skills. First is self-other distinction. There are so many simulations where we experience being embodied as another person, but there isn't a clear self-other distinction present in that situation. So really bringing that feature of empathic skill back into the training would really facilitate, I believe, a more mature empathic skills training. And then the sort of one of my personal interests is emotion self-regulation. Again, there's a lot of simulations that are really helping people to emotionally resonate and experience the distress of another person, but not so much that's really helping them become aware of their own emotional response. And I'll get into this a bit later, but most of the biofeedback that's used in VR today in a social instance is used to help us become more aware just of the other person's emotions, but not of our own response to that person's emotions. And then also communication. So one of my findings was that there's sort of this whole literature on VR and empathy. And then sequestered away from that, there's an entire literature on medical training in VR, and that has developed its own empathy communication coding system. And so part of my goal is to help merge those two subdomains so that we can develop better resources for a methodology to evaluate and establish empathy training in virtual reality. So why empathy training specifically for this scoping review? So if you search for the terms virtual reality and empathy, you get 39,800 results, which is quite a lot. But if you add the word training, it goes down to 453 results. So I was kind of curious why this differentiation and how can we further understand what VR can do in terms of really training these skills related to empathy, rather than just producing and promoting empathy as a cognitive or an affective state. So here are some examples of different skills that we can train in VR that are related to empathy. So I hinted on this before, but with cognitive empathy, there's virtual embodiment. Virtual embodiment, you can see in the top image on the left. And this is sort of seeing yourself from, seeing another person, seeing a first person experience of another person's body, and virtually experiencing their embodied point of view. And this is done very commonly to reduce negative biases towards people of a different social group. And there's also what I call virtual alterity. I just use my own term because nobody else has come up with a term for this. But it's sort of a level deeper, using some special sort of cinematic effects within a virtual reality simulation that depict the sort of sensory motor disturbances, someone's visual attention, their auditory attention, their thought processes. And it kind of goes a layer deeper to really helping you understand the subjectivity of another person rather than just seeing through their eyes. And I will give examples of projects that do this successfully. And then with emotional empathy, we're looking at using biofeedback, specifically heart rate variability biofeedback. You can also use breathing rates, galvanic skin response, in order to help people understand what another person might be feeling, as well as what they might be feeling in response to another person exhibiting strong emotions. And this emotion regulation training again has the goal to provide biofeedback and mindfulness-based cues to help a person relax their own physiological arousal in response to another person's emotions. And we see a lot of that happening in psychotherapy with interpersonal biofeedback, but not so much being brought directly into virtual reality. And then with behavioral empathy, there's these two features that VR can use to really get at teaching and training people on how to effectively respond in specific scenarios. So Gomara, who just before me, gave some really excellent examples for medical simulations. But essentially, simulation involves role-playing a scenario in a virtual environment to practice how to respond. And I think there's some really amazing innovations that can be accomplished in virtual reality with sort of a simulation of time travel where you replay a certain experience after sort of gaining certain skills or training on how to respond, as well as being able to see from different people's points of view around a certain situation. And I'll give some examples of both of those. And then another really key design element that virtual reality can use for behavioral empathy is self-feedback, the ability to communicate with someone and then swap perspectives and observe your own verbal and nonverbal behaviors towards that person, but from the other person's point of view, so that you have an opportunity to reflect in a sort of unusual way that we don't normally have so much access to on how we're communicating. And again, VR can do this in a very particular way because we can really see, you know, this embodied perspective of another person and how we are received in that way. So I'm going to give some examples of simulation and how it has been used to train behavioral empathy. And again, simulation is kind of like that role playing. So these are both papers from 2019, and they're both simulations of the bystander effect. So bystander effect is when people around a certain situation collectively immobilize, and then nobody really acts and helps because nobody knows what to do. They're sort of looking to one another to find out what to do rather than directly intervening. It's actually some of the reason that psychological research on empathy got started, because researchers wanted to know how this was possible. So yeah, in this example from Lev, Shapiro, and Jacobi, participants experience a drowning, and they see different bystanders around that situation, and they get a sense of their point of view, what each person's seeing, as well as their stream of consciousness, what they're thinking while they're seeing what they're seeing, and how that forms their memory of the event. So it gives people an opportunity to sort of understand why these bystanders weren't intervening. And so potentially then, if they were to undergo a similar situation, they would be able to reflect on this and use this as a tool to adapt more appropriately. And then in this simulation from Butler, it's a medical training for someone experiencing cardiac arrest. And again, it's training people on having a bystander situation and then feeling empowered to help. And these are some examples of cognitive perspective taking. So this is a Chicago-based company called Embodied Labs, and they created a simulation called the Alfred Project. This is to train young medical students who perhaps don't understand the sort of common sensory disturbances exhibited by older patients, one of which is macular degeneration. So they created this simulation where you're experiencing common everyday situations, in this case, like a family dinner. And you have this like black hole in the middle of your visual stream. And again, like this is an opportunity for VR to really capture the way that this sensory motor disturbance influences someone's everyday life. The As If project is quite interesting. So this is a project that is allowing people to understand how having chronic pain influences day-to-day life. So one of the features of chronic pain is that kind of randomly can impact you and you don't expect that it's going to happen. So in this simulation from Tong et al, you have someone tracing out different letters, and then in VR, a certain part of their body will be randomly affected by chronic pain as a simulation. And the motor feedback then will be declined for that movement so that they can't trace the letter as well, in a way as to simulate what it's like to have chronic pain. Quite a innovative way to teach that, I think. And then this is a project by Sujan An at Stanford, and she is creating this simulation of colorblindness in virtual reality and how colorblindness influences your ability to solve a task. So she has this puzzle building task, and there's a Confederate who's planted into the experiment who has colorblindness. And some participants go through a simulation where they experience what it's like to do the task with colorblindness, which is of course incredibly more difficult. And those who did experience that simulation were much more likely to compromise their own personal time and volunteer to help the Confederate in solving the puzzle tasks after the experiment. And these are some examples of biofeedback. So again, biofeedback is most commonly used in therapeutic settings for helping, for example, partners in couples therapy to better understand one another's emotions in real time. So this is called interpersonal biofeedback. And to use that as a tool to communicate about their affective states. So this is what I think VR can really adapt from. And I'll give an example of a VR project that does this quite brilliantly. This is a project by Javella and his colleagues. It's called Dynacom. And this is a group interaction, group meditation. And he used heart rate and breathing biofeedback. And when the biofeedback signals were synchronous, you have this sort of rainbow path building between you and your partner in meditation exercise.
Linda, you have 1 more minute, please.
Okay, great. I'm almost done.
Sure.
Perfect. Thanks for letting me know.
No worries.
So just some examples for future directions to really leverage the ways that we can train these skills in virtual reality. I really like the idea of being able to combine these different design features. So for example, combining perspective taking with biofeedback so that while you're taking someone else's perspective, you're receiving real-time biofeedback about what that person's feeling and then your own emotional responses to whatever scenario they're experiencing and how they're feeling. And then another example would be potentially something in augmented reality where you're able to see another person's biofeedback visualized in real time with cues that might alert you when your own heartbeat increases, for example, to engage in a breathing exercise to calm yourself down. That's all. Thank you for your attention.
Thank you, Linda. Thanks to all the speakers. So now we can ask questions. So I'd really like all of you to ask a question to Kate first. So I have a few questions here in the Discord channel, but Pablo, if you would like to ask your question directly to Kate, that would be great.
Hello. The problem is that I forgot my question, so I will have to read it.
Yeah, no worries.
But give me a second, or maybe Kate, if you can read it there in Discord, and
Yeah.
I can clarify.
So I see that the question is, in the AR scenario, the body movements of the digital human could be an important factor. Are you studying that from the beginning or just at that stage of your research, and how do you plan to address this? So we're currently looking at that at the moment while we're designing the digital humans, but it is something that we're also designing in. So to inform our process, we've actually made videos of people doing these emotional scenarios, both acting them and responding empathetically to the actor, so that we can kind of see the natural behaviors that people do, and we're sort of coding them by their, I guess, keywords in their speech prosody. We're also looking at facial expressions, their posture, and facial gestures they make and body gestures they make. So, and I guess from that information, we're currently just figuring out what can the digital human do with its hands and its shoulders, and what's appropriate for the different emotions. And I think that was actually quite a helpful exercise because it enabled us to see very subtle gestures that people do, like when someone was talking about feeling disgusted, they do a quick little jolt back, and the empathetic listener did a little movement back as well. So we're just looking for things like that. But so we are taking that into account. But yeah, I agree that when we're in the augmented reality study, the body gestures will be a lot more obvious, and particularly if there's an absence of them, it could look a little bit creepy because it's dead still but doing a lot with its face. So yeah, that's certainly something for us to really take into account when we get to that stage. And we're sort of just going along with the order of the study, so it might be a little bit down the track, but yeah, certainly something that we're thinking about.
Thank you.
Thank you.
Thanks. There's another question for Kate from Lauren.
Mhm.
Lauren, would you like to ask the question?
Sure, yeah. So I was wondering if you had considered how the uncanny valley might affect people's perceptions of empathy, because I've noticed like it looks like you're using maybe metahumans for your experiment. So like I was wondering, are you only going to use metahumans, or are you going to use different types of avatars? And yeah, if you think about it like metahumans, there's something about them obviously that doesn't look completely real.
Yeah, so we're using digital humans that are made by soul machines. I can actually put the link in the chat. So they're slightly different. And in our previous research, we've actually looked at the uncanny valley with them. Oh, sorry, I'm just going to send this. So in some of our prior research, we've had a qualitative study where people could openly talk about the limitations of the technology. And we also have run a couple of mixed method pilot trials. And within those, people again had that opportunity to openly report how they felt about them. And in terms of limitations that we had coming up, we didn't actually have people reporting that they found them eerie or creepy. And I guess this is after people have had an interaction with them. So maybe it's just when they actually have the interaction, they realize, oh no, it's actually not that creepy, or that sort of thing. So we haven't planned to look at the uncanny valley in this study, I guess based off those prior results with this technology, but it's certainly something that we could put in at some stage in these studies, even if it is just a open-ended, what did you like, dislike at the end of each study, so that we have that opportunity to check, did people feel that it was creepy? And yeah, because certainly if I agree, I think that if we do people find it's creepy, that will be a big distraction to the empathy response and probably mess with our results. So yeah, there's certainly something to it's good to keep track of. But yeah.
Yeah, thanks. I was just gonna say too, I think this would be really cool with deepfakes.
Oh, nice. Yeah, certainly. Yeah. Even like as an interesting comparator condition to digital humans as well. Yeah. Yeah.
Great. Thank you. So is there any other question for Guillermo? I think there is one question from Pablo for Guillermo.
I saw there was some
but not for Kate.
Sorry?
Oh, I was going to say, I saw there's some in the Zoom chat from Rory.
Yes. If there are more questions, then we'll have to come back because we are a bit concerned about the time. So we have about 4 minutes left in the session.
Oh,
so,
yeah, cool.
So yes, and please keep chatting on Discord or through the channel. But yeah, okay. So any question for Guillermo? Okay, so I think what I can read from Discord is Pablo asked, have you studied the importance of the mannequin in your setup? Can similar results could be reached by a pure virtual experience?
Yes, that is a great question, and that is those are some preliminary results for our mixed reality training. And when you look on the literature, everyone speaks wonders about mixed reality and how touching a patient or a virtual agent is actually better for basically everything that you live in VR, like presence or usability or empathy, empathic reaction, or what any variable that you want to measure. So they sell it as the best solution, but actually that wasn't the case for us. The setting up of the integration of the virtual mannequin is quite complicated. We have a lot of limitations with the movement, of course, as you mentioned. And yeah, at the end, the students don't really make a strong connection with the virtual patient because of the touch, right? And if you have these controls in your hands, I think it will be really hard to make kind of a connection with the mannequin that you're touching. So I think our results are perhaps, I don't know, like contradictory to the literature that we have found until now. Everyone's selling their prototypes as an excellent solution and an advancement to virtual reality. In our case, I think actually would be just better to keep it with VR without the haptic integration. Yeah, but this is just teaser. The papers will come so that it will be officially reported.
Great. Thank you, Guillermo.
Thank you.
Thank you. Any other question for Guillermo? Okay. If not, okay, great. Then any question for Linda?
I have one that I wrote in the Discord, but it's more provocative, I would say, than a real question for Linda. I'm not sure if you saw this old movie, the Clockwork Orange. There is this idea that you can force a person to think differently in that movie. So my question is, do you think VR will be a technology for doing so, which is kind of scary for me? Or in another way, how important is the will of a person in order to train these empathetic skills in a VR environment?
Yeah, I haven't seen the movie, but I read the book, which is really good. Yeah, I think of it as soft skills training specifically. So it's not, the intention is never to convert someone's thinking. I think perhaps an unfortunate circumstance that I've noticed just being a member of the Machine to Be Another is that people who are already quite inclined to be empathic are more likely to be interested in these experiences. When we measure like trait and dispositional empathy, generally for these studies, people are already quite high in dispositional empathy who volunteer to be part of the studies or to be part of the art exhibits. So I don't know, I guess my only comment to that effect would be that perhaps like the people who would have the most dramatic influence or effects from this type of training are generally not the people who are most interested in using it, perhaps.
Okay. Thank you, Linda.
Thank you. So I have one question for you, Linda. So I saw you mentioned you have looked into Google Scholar. So do you think Google Scholar is a good tool for searching papers for writing reviews, or there are other tools like Scopus or any other databases that you think would be better suited?
Oh, absolutely. I think other tools are better suited. I just represented Google Scholar because it was the most dramatic difference in terms of the search results that were coming through. I think it's a nice starting point to get a sense of those kinds of questions. You know, so for that question, it was how many articles are addressing these topics sort of on a broad scale, and then, you know, what does adding this one word do to the results that are coming through. I think when doing more specific questions, absolutely, there are much better search engines than Google.
Yeah, no, great, because I thought, yeah, Google Scholar indexes so many papers that of course the numbers will be dramatic there than other more defined sources. Anyway, great. Thank you very much all the speakers for this session. So let's thank them again. And yeah, so we'll have a quick break now for 10 minutes. We are running just 2 minutes late. So please come back in 10 minutes. We'll have the second set of papers presented. Okay, great. Thank you. Hello, everyone. It's time to get started again. So hopefully it's back. All right, so we have our first presenter, Magdalena. So we have got a message that they are not available to give the live presentation, but there is a video presentation. I'll start sharing the video, and then they will be available to speak at the end, answer the questions in the end. Okay. So first thing can you all see my screen? Yeah. Can you hear the sound? Sure. Can anybody please confirm? Can you hear the sound?
I can't hear the sound, no.
You can't.
No.
Okay.
I
So you
also
should-
cannot.
Yeah, you should share it with sound.
Share the sound. Okay. All right. Oops.
but also popularization of science.
Working now?
During past
Yeah, all
7
good now.
years,
Yeah, you should
together
maybe
with my
rewind
team,
and
we
start
have
from the beginning.
Yes,
That was good.
I hear the
That's
sound.
good. Thank you so much.
Okay, no worries.
actively participated in the open events like Festival of Science and Art, Open Day at our university, Scientist Nights, in which we were presenting the potential of the VR technology. In total, we have introduced it to almost 1,000 persons individually. That inspired us to systematize our insights and conclusions on differences in conducting research on VR social applications in the controlled laboratory conditions and in the field testing. Especially, the inspiration for this analysis was one case in which we were presenting a variety of applications with social impact. Among them, there was several empathy building ones. We have noticed that although people declare they appreciate this kind of experiences, they avoided them, probably because of the potential emotional labor. Okay, let's start with that special event. In 2019, we were asked to prepare a VR stand, providing an opportunity to experience applications with social impact. In June 2019, Poland celebrated the 13th anniversary of event that led to the free elections, and on this occasion, Gdańsk city held an event, celebration of freedom and solidarity, for the historical memory of those changes that took place after 1989. As a part of the celebrations, a social zone was prepared for the visitors near the Gdańsk shipyard and the European Solidarity Center. The zone consisted of several tents with different non-profit organizations like Zero Waste or Fair Trade. Our university, as a partner of Open Eyes Economy Summit, was to prepare a VR stand in a sustainability tent, which offered trying out VR applications for social impact. Our participation event lasted 4 days. Just to have a look on the circumstances, it was very sunny and hot. People were visiting the event with their friends and families. The atmosphere of the event was rather vivid, crowded, but also very energetic. We wanted to present various applications of VR with which society could benefit. Every visitor of our stand could choose among several applications: therapeutic, relaxing versus educational versus perspective taking and empathy building. So how was the procedure? A session of each participant lasted about 15 minutes. After a short introduction concerning the technology and available experiences, the safety aspects, contradictions, and potential side effects were explained, and participants signed an informed consent. At the beginning of the experience, the interaction with controllers and rules of teleportation were carefully explained, as well as using Guardian Zone as a border of the roomscape. To those participants for whom it was their first VR experience, the introductory part was longer, and it started from more passive and static experiences, and then we passed to more interactive ones. Usually, an introductory part was conducted using Steam Experience the Lab. The second half of the experience was to be chosen by the participant from the selection presented in the slide. After that, they were asked to fill in the immersion form to assess the application that made the greatest impression on them. Very often, the session ended with a deeper discussion of the potential of VR and existing and possible future applications of this medium in different fields. Let's have a closer look on the applications that were available to choose. Becoming Homeless is an interactive story in which the attendant experiences main character becoming homeless. It lasts 8 minutes. Notes on Blindness is an experience that visualizes the process of losing sight using first-person perspective and narration, and this experience lasts about 8 minutes. 360 movie by the Open Cages Foundation is showing cage rearing from a perspective of a hen. Its duration is 2 minutes. Nature Tracks VR provides relaxation through exploring natural landscapes from various climatic zones. The Blue allows for experiencing the beauty and biodiversity of the ocean. The Body VR Journey Inside a Cell is an educational virtual reality experience that takes the user inside the human body. And finally, the Tilt Brush is a 3D artistic content creator. As a research tool for measuring user experience, we used a shortened version of the immersion questionnaire, and we adapted Polish translation and shortened it to 9 questions. Now we'd like to share some insights from this investigation. Only 30% participants has chosen empathy apps. It happened very often that they were interested and even surprised that such experiences as VRPT for homelessness, blindness, or hands conditions exist, but they actually decided that they wanted to try something relaxing or therapeutic. Only about 30% tried becoming homeless, and nobody picked the blindness experience or a 360-degree movie of a hen, even though the foundation Open Cages has had its own stand in the same tent. And we assume that although the participants were aware and appreciated the significance of such applications, they did not want to take this emotional labor, especially in that context of that open event. And the reported immersion levels were high for all the experiences. The Intergroup Statistics comparing the immersion each applications are not statistically significant due to small and unequal numbers of testers, but we presented in the table. There were also no regularities in the relation between the perceived immersion and participants' age and previous VR experience. There's something special in the heterogeneity of the group in the open events. They provide easier access to reach more diverse group of testers, especially compared to the lab research where usually students of particular faculties take part in the experiments. This allows for exit from the bubble of people of the similar profile. This is for both age of participants, see the histogram on the slide, and their technological competences as well as beliefs and lifestyle. In particular, field testing allows reaching and gaining opinions from people for whom VR is not easily accessible in their everyday life. For some types of lab research, depending on the goals, this heterogeneity is not desirable, and purposeful selection is applied with use of pre-screener, which will be more difficult to process during the field testing. For those participants for whom it was their first contact with VR technology, in our case it was about 70%, the effect of new experience and emotional attitude to it could have impacted the declaration in the questionnaire. The attitude could also be influenced by positive or negative opinion shaped by information from media. In the onboarding process, the digital competences correlated with playing video games, for example, are particularly meaningful. We have observed that children and regular gamers started interacting in VR more easily, and the onboarding process is also very demanding to the researchers. They should be empathetic, of good manners, and adjust the rate and the detail of provided support to each tester individually. If a tester has already tried VR technology before, then the attitude to the presented apps could be influenced by the quality of the former experience. We sometimes met people who were discouraged to the VR technology in general because they experienced, for example, simulator sickness in the past, usually with the older generations of headsets, or improper implication selection, for example, trying a roller coaster as the first experience. While in the lab, experiment usually the only observers are the researchers. During the field testing, a participant is aware that their companion, family or friend, or anyone from the event can observe their performance. And sometimes it plays an integrated role, people giving cues to the tester, but it can also make the tester less natural and afraid if they will be able to cope with the task, especially in VR case. They are sometimes afraid of looking and behaving weird while wearing HMD. The research process in the lab is usually highly orderly and carefully planned, while during open events, some spontaneous disruptions are highly probable, and researchers must be flexible to various circumstances and ready to adjust the procedure by improvising. This makes the control over the experiment more difficult and the results less regular and less interpretable, especially in the qualitative approach. It happens more frequently that responses decide not to continue the procedure, sometimes for the simple reason that they hurry up. The work of researchers conducting the field testing is usually more exhausting than during the lab experiments due to the more irregular procedure, the necessity to be more flexible and dynamically adapt to different testers with various background, competences, attitude. And the cognitive load is also related to the dynamics of the experiment and the higher emotional arousal of the situation. Both the irregularity of the procedure and a set of additional aspects which should be taken into account by researchers is also discussed by Bylinson while reporting the Empathy at Scale project. Contrary to the lab conditions, field testing has the advantage of more informal meeting atmosphere, and participants are usually less tense. They let themselves to be more expressive than during following the procedure in the lab. On the other hand, in the lab, participants are usually more focused. That does not mean taking the experiment less seriously. If placed during an open event, usually they do their best to apply to the procedure, but treating it more like a part of entertainment than a rigid task. This effect is particularly visible at the end of the experiment during the contextual interview, when they usually were more relaxed and enthusiastic. At the same time, in the field testing, the participants are usually more impatient and they have less time for a session or particularly for filling in the forms. And this was the reason for shortening the immersion questionnaire to 9 items. Because in the pilot study, first testers complained it was too long. This aspect limits the opportunity to apply larger battery of questionnaires. People could have tendency to avoid them or fill them carelessly. Taking into account both advantages and shortcomings of field testing, we assume that this form is perfectly supplementary to the lab testing, and it is worth this additional effort to reach more diverse group of respondents and gain their valuable feedback, especially when we talk about applications designed to help others and change their perspective of thinking. In order to validate their impact and make real influence on human attitude, should be more available to the widest group possible. Thank you for your attention. Please contact us for more details.
Great. Thanks for the talk. I need to stop sharing the screen. Okay, Magdalena will be available for questions in the end.
Hello. So I'm very sorry for the inconvenience. Actually, it happened exactly that my daughter has woken up, and I'm not sure. Maybe we will. Maybe it will be okay, and I will be able to answer your questions.
Do you want to do them now, or we plan to do the questions in the end of the session? Whatever.
Okay. I can adjust to you.
Okay, so maybe if anybody has any questions, or maybe you can then take care of your child. So if anybody have any question for Magdalena, please ask now. So I have a question. So the studies that you have done, so how many people were involved in those studies in general?
It was 44 participants. In fact, we had more volunteers, but not everyone agreed to fill in the questionnaire because sometimes they didn't have time. They were hurrying up, so only part of them really participated in the investigation, and the rest of them just has tested some peer application, and that was all. So the number was not really high, although the event was really big and it was 4 days. So it also illustrates the role that in the open events we have only some small percentage of people who are who agree to and volunteer to participate in our research.
Oh, great. That sounds good. Okay, thanks so much. If there is no other question for Magdalena, then yeah, thank you again. And yeah, please see if you can on Discord or other channels that people may contact you later on for questions. But thanks for joining and thanks for sending that video. Okay, all right. So
thank you very much.
Right, no worries. So now I need to move on to the next speaker. Sorry. So our next speaker is Iona, and they will speak about designing and implementing individualized VR for supporting depression. So I need to make you co-host. So yep, over to you, Iona. If you can share your screen, please.
Thank you. Beginning. All right. Hi, I'm Ilona. I will be talking about the project designing and implementing individualized VR for supporting depression. Just to give you an overview of what am I going to talk about. First, I'm just going to give a short introduction, just a brief background and what our goals are in this project. And then I'm going to talk about the IVR design and implementation process. And also, I will give a short demo of our prototype. And I'm going to touch on the results of the pilot study that we conducted as well. And then finally, I'm going to talk about the next steps of this project. So, introduction. So mental health disorder is very prevalent in the society, especially with COVID going on. I think more people are having mental health mental health disorders, and it's putting a burden on the healthcare system. So recent studies support the use of VR in the treatment of mental health disorders such as PTSD, phobia, and addiction, where they can kind of give some kind of exposure therapy, like simulating an experience that might not be easy to simulate in the real life, and also to give like a safe kind of environment for them to be exposed to these situations. So one of the most common mental health disorder in this is depression. But despite how common it is, not much is really known about VR and the treatment of depression. So we aim to investigate if VR can be treated. VR can be used to treat and prevent depression, and also to investigate if introducing individualization can provide benefits to individuals with mental health issues and their therapists. So in the IVR design and implementation, we are trying to design and implement applications to aid recovery from depression by improving self-compassion. So there's actually a link between self-compassion and self-criticism with depression. So self-compassion is known as protective, and self-criticism is known as a risk factor of depression. So people with higher degree of self-compassion, they tend to not have symptoms of depression, while self-criticism tend to be linked with higher of. So one of the treatments for depression is through compassion-based therapy. So here, the aim of the treatment is kind of to improve the patient's self-compassion, to also improve their symptoms of depression. So this IVR application is based on a previous study by. So in this study, the participants are given an application that gives them a chance to give compassion to a young person in distress. So the girl is crying, and then the participants are given the chance to kind of comfort the crying girl, and also it gives a chance for the participant to receive compassion. So after they give compassion, they will be in the receiving end of the compassion speech. So the point of view is kind of switched. So building on that, we are adding on an element of individualization. So we give them some choices in the beginning. So we give them a choice of virtual bodies that they will embody in the first and second scenes of the application. They're also given like a choice of therapy environment that they prefer. They can choose whichever they're most comfortable with. And also we give them a choice of in-game characters to interact with, and also the choices of scenarios they're going to be in. So in the virtual body selection, they can have some choices. The choices for now are preloaded models. So they can choose between the avatars that they like. They can choose whichever reflects them the most. And then they can also choose therapy environment. For now, we have both indoor and outdoor environments. The indoor ones are the living room environment, and also a study in a Victorian house. And we also have an outdoor environment. Basically, it's a park. In the future, we might want to add more, but currently we have these two. these three outdoor and indoor environments. And then they can also choose which character they want to interact with. So we have two choices here. First is the Hannah. Hannah is a young woman, and Roger is a young man. And then they can also choose which scenario they want to be in. So they want to console a crying Hannah, or they want to be be in a scene where Roger is upset and they have to comfort him. So I will show you a quick demo later on, so you can see how that goes. So after the participants choose the first the choices in the first scene, then they will enter stage 1, where they can deliver compassion. So the scene here will be loaded based on whatever they chose, and then they can practice the 3 phases of compassion focused therapy. So here they since this app is meant to be used in a therapy environment, so maybe a therapist will be there. They can practice giving these 3 stages of compassion. So first, validation, you kind of acknowledge the other person's emotions, and then redirect their attention. So kind of distract them from redirect their attention to a more positive thing, and then activating memory. Kind of want to prompt the receiving the other person to kind of remember a positive experience. And then after they have finished delivering compassion, they will go to stage 2, which is receiving compassion. So now the end user will experience the previous scene from the crying or upset character's point of view. So it's kind of flipped, and then they can see how they did in the first one. So whatever they said in the first stage, they will be able to hear and see in the second stage. So this is a video demo. In the first stage, they can kind of choose their avatars, and since in this scenario, girl, and then environment, and also choose character to interact with, and the scenario they want to be in. Now they can start, and then based on the choices, it will load a scene with a crying Hannah, crying girl. For example, like this. So, and then they will practice delivering compassion here. Yeah. So they can practice delivering compassion here until they are comfortable. And then when they're ready, they can go to the next stage, and then they can hear a playback of what they said in the first stage. So here they will be the crying girl Hannah, who is receiving compassion from the virtual app. So when they're done, they can go to the main menu, and they can choose either to repeat and practice again, or they can choose to end the application here. Sorry. Okay. So we have recently conducted a pilot study with sample size of 23, 5 females and 18 males. The mean age is 24. In this pilot study, we're using an earlier prototype. We use a PHQ-9 questionnaire to measure their depression, and also have them fill out a subjective questionnaire in the end. What we find is, regardless of their PHQ-9 score, most participants, they feel that the introduction of individualization features makes the VR app more engaging. We also reach out to 7 clinical psychologists to gather their feedback. So most of them believe that the introduction of individualization IVR would help them increase their knowledge of clients who just to get like more discussion points from their choices and their actions within the application. So the next steps of this project is we want to gather data from bigger sample size. Currently, this project has been approved by MESI ethics approval, and we are starting to recruit participants. And then we also want to do something in the future where we introduce more robust interaction between participants and the virtual environment, since right now there isn't really much interaction between the participant and the virtual avatar. Possibly adding some artificial intelligence to the avatar to improve interaction as well. So maybe we can have the avatar respond to whatever the participant is saying, or maybe they can interact with a grabble with an object that they can touch and give to the in-game characters, for example. So that is what we are doing in the future. Yes, so that's all from me. Thank you for listening.
Thank you, Ilona. So we'll have, now I'll present our paper, and then we'll have a question and answer section after that. All right, so today I'm going to talk about a study that we have recently done using augmented reality and laptop and sharing physiological signal to increase increase the sense of collaboration between the users. The study was done by my student Yufei as part of her honors project when working with us at the University of Queensland. So when we talk in person or collaborate in person, we have a lot of cues shared between us, like a lot of body languages, then eye contact, then the tone of our voice, and all of those things are not available, or many of those things are not available when we collaborate or chat over digital medium like Zoom, like what we're doing now, or even when we collaborate in more immersive medium like AR and VR. Right? So our lab focuses a lot on how we can make this remote collaboration remote collaborators feel more connected within XR, and how we can make it more akin to the real world scenario where people can feel more connected to each other. So one way of achieving that is sharing physiological signals. Physiological signals like galvanic skin response, heart rate, and things like that. So there are other researchers who have in the past explored this area. For example, Tan et al. In 2014, they used a similar video conferencing setup, but shared information like galvanic skin response or blood pressure or respiratory measurements in a visualization like this. And what they found was that physiological cues increase co-presence. Co-presence means when two of the collaborators feel each other's presence a bit more. So, and then following that, we did a lot of studies in the VR domain. So first study that we have performed in this area is published at CA in 2017, where we shared physiological cues between the two collaborators when they're playing a VR game. So one game was a calm butterfly collection game. The other one was a bit scary, a zombie shooting game. And what we found when these physiological cues were shared, there were higher positive effect. And then collaborators communicated a lot more with each other. And following that, we did another study where we shared heart rate feedback in a bit more interactive scenario and 3 different level of interaction. So one was an escape room game where people have to work together to solve a puzzle. The other one was an exploratory environment where they were just exploring. They didn't have to interact at all. And the other one was a furniture arrangement game where one person had to take a lead role and other had to follow. Right. And what we found was when you shared that heart rate feedback, again, the social presence increased overall, and people understood each other a bit more emotionally. And also when they had the heart rate feedback, they felt more dominant when performing the task. And then we followed up with another study where we shared the heart rate feedback, but this time we manipulated the feedback between +20 to -20% of the original feedback. Right, and then we had 2 different setups, again, a similar exploratory environment and another one a bit more scary zombie setup. There we also found that people, when you shared the feedback, the emotional awareness of the person was increased in the passive environment, which means the exploratory environment, and also the manipulation of heart rate changed the real heart rate slightly as well. Now, one question that comes to my mind when we're doing the study is that all of those were in the VR environment and just a single type of an environment. Now, how about the asymmetric platforms where we now that we are increasingly using AR, VR, and other platforms together? For example, with these conferences, there is a part that is running in VR. We can do this in Zoom, and there are other channels we are using. So this is an area that is going to flourish and get more attention. So we wanted to know what happens if we share this type of physiological signal in an asymmetric platform. Similar to this, where let's say a group of people or one person is in the augmented reality setup and using an augmented reality device, another person is using a laptop, and they're collaborating with each other on the same environment. So with that in mind, we designed this mixed factorial study where there are 2 people. One person was in the using a laptop, another person was using a Microsoft HoloLens 2. They were equipped with Empatica E4 band to measure their physiological signals, and it was in the lab. So we we recruited about 20 participants for this study, divided into 10 groups of 2 in each, and most of them were from the university. So the mean age group were around 24 years. So these are the 2 environments that we have designed. So one was a competitive task where they had to really follow a ball and find the ball within the first click, and then they would see their score and a high score theirs to make it a bit more competitive. And the other task we designed was a collaborative task where the person is sitting on the laptop had some cues. They knew the numbers, and person who was in the AR using HoloLens, they could only see the letters, and they had to collaborate to find the right block. So these are 2 different tasks, and then we had in one condition we had the heart rate feedback on, in the other condition we had the heart rate feedback off. So one thing to mention here is heart rate feedback that we provided. It was a synthetic feedback, so we didn't collect the heart rate feedback or shared their own heart rate feedback in real time. But participants were not aware of that before the study. They were told about it afterwards. And the heart rate feedback was audio-visual feedback, like as you can see here. It also showed the heart rate at that point in time. So this environment was a within subjects variable, and the heart rate on and off was a between subjects variable. So in terms of dependent variables, we collected the raw heart rate and skin conductance, both phasic and tonic components, and then positive and negative effect schedule, which measures 20 different emotions and effects. And then we we use inclusion of other in the self scale, and then we also did a semi-structured interview. So we hypothesized that while having heart rate on will increase the positive effect, because that's what we found in our earlier studies. And for the collaboration task, we expected to find a higher rating for iOS scale, because people feel more connected to each other while collaborating. And for AR users, we expected a higher heart rate because they were standing and moving, whereas the participants with the laptop was just sitting. And then we also expected the competition task will increase their higher skin conductance based on the earlier literature. So in terms of the PANA scales, we did not really find any effect of heart rate or the task on the positive and negative effect. But what we found is a significant difference in the ratio of positive and negative effect. So this ratio is about, for each negative effect caused, how many positive effects were caused. So overall, if the number is above 2.9, it sort of shows or indicates a flourishing state of mind. Or in general, the higher the number, the better. All right. So what we found is collaboration task had higher positive to negative effect ratio than the competition task, which is expected because they're collaborating and not fighting against each other. And then in terms of the inclusion of other in self scale, we found what we expected. The collaboration task caused higher inclusion, higher rating in that than competition task. And interestingly, also found that the person using AR devices had higher iOS rating than the laptop. And this is most likely because of because of their immersiveness, and also if you look at the setup, the AR person could see the laptop person, but the laptop person was not seeing the AR person all the time. So that might increase their rating. Okay, so now for the GSR, or we found that for the SCL component of it, collaboration had higher SCL values than the competition task. And similarly, for the SCR values, we found that competition task had higher values than collaboration. So normally SCR is more varied component of the skin conductance that changes quite frequently. So because they are competing, so they had higher arousal, so it varied more. Whereas the SCL was a bit more static, and it changes slowly over time. So in general, looking at the hypothesis that we had, so the first hypothesis was not supported. The second hypothesis was supported. The third was not supported, and the last hypothesis was supported as we expected. So although we did not find overall in our work that the heart rate had a direct impact on or a major impact in general, or significant impact, but one thing which is quite interesting that we found that and notable in this work is the ratio of positive to negative effect was higher in the AR condition, or for the AR users, when the heart rate was on. So if you look at this this graph for the collaboration AR and competition AR, you'll see the red bars are higher, but on the other two cases, the red bars are lower than the blue bars. So it is an indication that, and then I think the p-value was around 0.08 or something, so very close, but not quite significant. This is an indication that perhaps augmented reality users and interfaces can use this shared heart rate feedback to increase their overall positive negative effect on or achieving higher flourishing state. But what happened in this study was, because it was only a small task, and then the interfaces were not probably designed the way it should have, and the tasks we used were not suitable to trigger some of these effects that we were expecting. So in the future, we would like to expand on this and try other interfaces and other types of tasks to measure these effects. Yeah, so that's all I had to say. Thank you very much for listening. And now we will move on to the question and answer session. So if any of you have any question for us, please ask.
I think there's a question in the chat for Alona.
So Roddy, would you like to ask your question to Alona?
Thank you for your interesting research for all 3 years. Yeah, so just looking at how therapists interact with their clients, I wasn't too sure if your studies targeted towards the client or the therapist, but yeah, I could see how using this for potential therapists so they can understand a more diverse clientele could be really beneficial for them. But perhaps for clients, it might, you know, if they have a bad experience, then they'll not really believe in the therapy. So you're just wondering if you have any comments around that.
Right. So this application is intended to be used like by therapists, their clients. So the client will be using the VR headset, and then the therapist will guide them to the experience. So the point is to give them like a controlled environment for the clients, so they can experience a situation where they can practice giving compassion and receiving compassion. So this we're just trying to train them to have better self-compassion. So throughout the experience, their therapist will guide them. I think it's a good idea. I can see the potential of this being used for training for therapists that just started their careers, but I guess it is outside of the scope of this project, because I think for it to be useful, we might need some intelligence, sort of better interaction with the simulated client and also the therapist.
Yeah, I think there's a lot of work that could be done in the AI with all of these embodied conversation agents. I mean, I'm not too sure if many people are working on this or not, but there's definitely a lot of demand. Yeah, thank you.
Yeah, I reckon. I think we are already planning on the AI in the future, just not in this stage of the project yet.
Fair enough. Thank you.
Is there any other question?
I had a question for you, Arindam, about your study. So you looked at
Sure.
heart rate and GSR. Do you think there are other physiological measures you could be using? It seemed like the heart rate provided kind of mixed results, but I wonder if there's any other measures that you've got that you think could be used in future studies.
Yes, one idea that we are considering is using EEG devices to measure their cognitive load in real time, like what Anatol shared in his talk, that you can measure cognitive load in real time. And I also have a student who is looking at measuring emotion in real time based on the physiological signals. Now, if we can, once those things happen, then if we can share those directly to the participants, that might have a different effect. So yeah, that's what we're planning to do. I guess we need to share feelings or other things that are more understandable. So we started with heart rate because people understand what heart rate is and how it varies. Yeah, and we are seeing this type of results, but other things like GSR or pupil dilation and this type of things we can share, but I guess the users will not really understand what they actually mean. Right, so that's something we're considering for future. Right. Okay, so if there is no other question, perhaps we can take a break now. So
I wonder if it would be good for Janet, if she's online, to explain a little bit about the brainstorming task after the break, so people can kind of get ready for that. And then when we come back, then we can do the task, because you might need a couple of minutes to explain Looks like there's 20 or so people online, so we can probably break up into three groups or so.
Yeah. Okay. Yeah, so the next activity is sort of a group activity where we're going through a brainstorming session, and I can just sort of share off screen. Oh, there it is. So we're using a tool called Mural, and I'll copy these links when we're back. When we split into groups, each group will use a different board. When you click on these links, this is essentially what you'd see. So you can just enter as a visitor, or you can put in your name and your email address, but it's optional. But just to go over the activity itself, the key idea sort of behind the activity is to brainstorm about like research topics or important topics in the field or open problems, and then do a deep dive into it, look at either solutions or research studies or research methods or just challenges in general, but just think about it a little more deeply. And so it's split into two broad parts. So we'll do 1 to 3 in one go, and then we'll take a break and come back to the bigger group, and then do 4 and 5. So when you open the Mural board, the link, this is what you'll see. You'll have a couple of tools here, which is you can make sticky notes. You can use sort of like add shapes or like draw something. And the first 10 minutes is just to brainstorm. So you can put in pretty much anything that comes to mind. This is sort of where you maybe don't want to filter too much, don't think about it as much. There's nothing too simple or too wild out there. So anything that like is of interest to you personally, or that you think that the field should be moving towards, you can sort of put here. And then the second activity, or the second sort of part in it, is where you would group these topics. So that's sort of a way for us to sort of cluster these topics and see what the broad themes are. And if you have more than 3 themes, we would ask that before you come back to the main group to talk about these topics, that you pick, like you prioritize and pick 3 to bring back. And so when we're done with that, we will come back to the main Zoom event. So these would be in 3 separate breakout rooms, and Arindam, Mark, and I will facilitate each one. When you come back, we will have these 9 topics that from the 3 groups, and we can vote on, again, we'll like filter through again and vote on the 3. We'll vote on 3 that we will do a deep dive into. So we'll vote on these topics, we'll pick 3, and then we'll break out into 3 groups again. Each group will pick a certain topic and do a deep dive. This is more free, so you're free to like have a conversation or draw a flowchart or a visual map of the research space, whatever feels right for that particular topic. You can do in this space here, and then we can wrap it up and talk about key points, and then come back at the end of it and talk about it as a group. So the first 3, when we break out into breakout rooms, I think we might do random groups, or we can just pick, just so we know that there are enough people in each of the 3 groups. But once we pick the 3 topics to do a deep dive on, you can pick the topic that interests you the most and go to that breakout room for the deep dive. But that's the general structure of like what to expect, I think, when you come back. Let me know if you have any questions or concerns. All right, so I think we can go into the break now.
Yeah, so we'll wait till what time, Arindam? Do you want to go to 15, so 8 minutes? Or?
I think the next session starts at 20, so 13 minutes.
Okay,
yeah.
Or great, that sounds great. Okay.
Yeah. Okay, so we'll be
So
back
we'll come
in
back
13.
at 2:20, which is 13 minutes from now.
Yes, okay.
Okay, good. I'll see you all
soon.
back then.
Okay, see you soon.
By advertising on YouTube, I catch the eye of my ideal customers at the right time.
Oh, wow. That is very interesting. A long time ago, in what felt like another universe, I saw an AR headset called Magic Leap. Magic Leap 2, I just got the demo here in New York, and it was a whole different experience. So Magic Leap has made a complete pivot and went fully into the business territory. Now with the new CEO, Peggy Johnson, it is looking at verticals like defense and medicine. And I got to take a look at it in New York in a regular conference room where I put it on and went through a couple of demos. Now, here's the thing you need to know about Magic Leap and about AR headsets in general. There aren't that many of them. Now, right now, the big ones you wear on your head like helmets are the Magic Leap 2, and Microsoft HoloLens 2. The Magic Leap 2, the design is a lot thinner and more compact than what the HoloLens 2 is, but it also has this separate processor pack that you still have to wear on your hip. That's the same as the original Magic Leap. Plus, it also has this handheld controller, which is also similar in concept to what the original Magic Leap had. Although the Magic Leap 2 does have eye tracking and it does have hand tracking, I didn't get to demo all of that stuff. I really was looking at stuff that was about the display and about that controller. Now, when I looked at it in the conference room, there was some light coming in and there were a couple of demo stations where I tried on different headsets with different demos. This is early hardware that I looked at. The actual headset is supposed to debut later this year. Magic Leap is aiming to have
Janet. It looks like our numbers have dropped. Only 9 people, huh?
Yeah, I was gonna say, I guess one mural board's good for now.
Well, we'll see who else turns up. Rory's there. Hey, Rory. And yeah, from Japan. Great. Maybe a couple more that drop in as well.
So we have 10 of us. So do you think one?
I think one will be fine. That'll be great.
Yeah.
Yeah. Let me just share the. Yes, I think if we go to that link, you should be able to see it, and I will share my screen as well. So you should be able to like click on, say, brainstorm on the outline essentially, and it'll take you to that particular. So if you click on brainstorm, it'll take you to that region. And then I think a double click will give you a sticky note, which is all you really need.
Okay.
And so this part, I don't know if you want to do it differently. So like, because we're only 10 people, we can sort of decide how we want to do it, but we can sort of, I was thinking we'd just do sort of an individual brainstorm of just like throwing in research topics or ideas or things you want to discuss on here. And they don't have to be related to exactly what was talked about today, but just generally in the empathic computing sort of umbrella works.
Yep.
Okay, so I'm just going to hang the interface here. Okay, so in the brainstorm box, number 1, that's where you want us to put the brainstorm ideas, and we can make our own.
Yeah, you can
make our own.
Yeah.
If
you double click,
you want us to write down what we think are some of the key research questions, topics in the field. Is that right?
Yeah, and I think in this stage, you want to sort of just go for either volume or like don't filter what you're thinking. But if you double click, you'll be able to like create a sticky note. If not, actually, I think you only have 3 buttons, but this button here, the one right at the very top, will give you other sticky notes.
And this is going to get pretty messy pretty soon, maybe.
Yeah, in the next step, we're actually going to try and group things, and we can either do it together or I can do it while we talk about it as well. But messy is fine for now.
I've got a few more people who have joined us. Janet, I'm not sure if you want to explain.
Oh, yeah,
I
I
need
can.
to post again in the
Yes.
chat window the link so people can join because they won't see the link.
Yes, I thought I was sharing. I am sharing.
Samad just joined, I think.
Yeah.
Rio, Kunjao.
So for anyone who joined new, we're working on, can you hear me? Yes. This, I posted a link, it's a mural board. And so, for example, what you'd see is you would get to this, you would get to essentially this board. We're in the first part where if you click on brainstorm, you'll be taken to it. And what all we're doing right now is writing down any research topics that you think should be addressed in the field or are interesting to you personally, or things you want to see more research on. And right now, we're not filtering for quality. We're not thinking too much about what it means or the feasibility of it or whether it's important for the field. We're just looking at, we're just sort of brainstorming for quality right now. And so you can double click. So if you, oh, you're still, sorry, I think you're still seeing the wrong screen. All right. Just give me 1 second. I'll bring this back here. Yeah, so to go over that again, once you're in the on the board, you can click on brainstorm. It will take you to this little piece of the board that we're working on right now. And you can just double click anywhere, create a sticky note, write your idea down and then move it over, or just and you can add as many as you want. There are no constraints, no restrictions right now. And we'll probably wrap up this portion in maybe 2 minutes. We can give anyone everyone some time, or you can just let me know when you're done and we can move to the next part.
Yeah, let's give another 2 minutes and then we should move on to the
Yeah.
next part. Yeah.
Okay.
creates brain part.
Excuse my lack of knowledge here. I'm just wondering what the area of the brain that has to do with emotions. Is it the prefrontal cortex or is it a different region? Limbal system.
Yeah, I'm not sure, Rory. I'm
just...
sure some smarter people than me that knows about it.
No, I should be there.
I'll look it up.
I should be there.
Okay. All right, so shall I move on to the next part, Janet?
Sorry, I was on mute. Yeah. We can move to the next part. I'm still unclear about what screen you're seeing because Zoom seems to like, I don't have the green thing. So can you actually see my screen?
I'm seeing a screen. Not sure it's
Okay.
your screen, but it's definitely a screen on Zoom.
Okay, so that's probably mine.
I presume it's your screen.
Yeah. So yeah, no, this is great. So we have like quite a few things here. Now the second thing we're doing is actually grouping them in similar research topics. So we can group them in clusters. So you can start with the ones sort of that you created. And if you think they're separate, just put them in different locations. And but as we'll sort of go through these and group them. So
do you want to make some cluster headings and maybe a different color?
Yeah,
once you've got a couple of notes that put together, maybe somebody can write a heading saying this one is green or something, or blue, or this relates to, I don't know, emotion, or this relates to.
I can just create these like little areas for now, and if we run out, actually we might run out.
Yeah, probably more than that, more than two. So yeah.
Yeah. Once you zoom. We can just have them in the rough area, and we can, I can sort of give them different colors later.
Sorry, I'm just grabbing other people's stuff, just trying to match things. So I apologize if I've.
Oh, that's great.
Oh, no problem.
That's really cool.
And so they're vague areas, but don't feel like you have to stick to those areas. And we can all sort of do this. So let me also.
There's a really tiny note there. I don't know who it belongs to. I can't actually read it. Oh no, I can zoom in.
Yeah, I can make it.
Oh yeah. This is quite a cool tool.
Yeah, it is, isn't it?
It's a little helpful when everyone's remote.
Yeah.
Bella, come here.
Also, I just want to point out if you're confused about what something means and you want to call out a sticky note, maybe whoever made the sticky note can give more context. Another share it down. We could just save time because we have a few stray ones, but it might be helpful to actually go over each one and see what, if we think it should be split up into different groups, or if we agree that everything is sort of similar. So the first one is what I called it multi-user support, but it's how to convey empathy in multi-user platforms, scaling and detecting emotions from a large group, shared user experiences and emotions being experienced in different systems, in person and across the web, and multiple people controlling a single avatar and controlling multiple avatars. Do we all agree that these sort of fall under the same thing, and is there a better title for it?
Yeah, that sounds good. So for now.
The second sort of box is understanding the areas of the brain that respond to emotions and the signals that the brain is giving, how different emotion is experienced in VR compared to the real world, and how people shut down their emotions from extreme situations like war or loss of a loved one to manage their expectations or become empathetic to others, and to what extent empathy can be taught or honed through practice in an innate process. And I think I saw a few that might be, this sounds more like just really understanding empathy and how people perceive and react to empathy. And so if there might be a few others around, so if you know of any sticky notes, we can move them up there, but I think that's the...
Yeah, it looks like a good group. Sounds about right.
Okay.
So the large group one, is it sort of like, you know, a group of protesters or something, or, you know, how different large scale groups behave and how to interpret it? Or
I put that in. That was could be in any state. So for example, in Australia, CSIRO have written a tool that data mines tweets, and from that they can get the kind of an emotion of a country. So if they look at all the people who are tweeting from Australia in a certain day, they can data mine all those tweets for certain emotional terms, and they can say, oh, well, these people are feeling positive or negative, or the mood of the, so that's at a country level. But you can imagine on a smaller scale, if you had a social VR environment that maybe had 100 people playing a game together, maybe there's some way to measure emotion of the whole group, whether they're all enjoying themselves or not. Or if you're doing a concert and you've got 1,000 people in a virtual concert, how do you know if they're all having fun or not?
Right.
So it's kind of going up from 2 to, well, I guess Anatole talked a little bit about the difficulty of measuring emotion for 5 or 10 people, but when you go further from that, have dozens or hundreds.
Yeah, I can see the complications there.
Yeah.
Right, so there's this one, which is how people empathize with animals, how you communicate with autistic people or people who have damage to the limbic system, understanding users' needs and desires with respect to emotion representation, how to adapt an interface based on the emotions and or cognitive load, and the user groups that learn extreme behaviors such as criminals and children. I think there might be 2 separate things here, so I'll just move, hang on, sorry, I'll just move this. So I think there's representing, or like, I guess, visual cues or any sort of cues for emotion and how to represent it. And then
So
I don't know if we'll keep these as separate.
So this perceiving emotions, maybe do you think it will be a better title to have like different user groups? Because we're talking about particular user groups here. So.
Right. And oh, sorry, was this here? I don't know if that was part of that. And the next group was these 2, which was sort of how we adapt the interface based on cognitive load on emotions and understanding users' needs with respect to how we represent that emotion. And then, I don't know if we were talking to time. Okay, we can move on to this one, and then if we find something else that fits with that group, we can move it there. The next one was, I think, I broadly categorized it under collaboration, although we can sort of split it. The impact of spatial audio on collaboration, interaction techniques during collaboration, using a virtual character to mediate collaboration, empathic tools to enhance video conferencing, and generally communication models and collaboration in AR or VR. And what cues or signals are important for the different types of tasks during a collaboration, impact of nonverbal cues, and enhancing avatars to improve collaboration. I think that's broadly collaboration. Do we want to split it or keep it as is? And there's brain synchronization, which I don't know the context for that. Is it that's during collaboration?
Is that during collaboration? So Anatol talked a little bit about that during his keynote when he had people playing games that were competing or collaborating with each other.
So perhaps we should have another group for visualization, like here, this one, like what cues and signals are important.
Yeah,
so
we can move. We can move it here, which is, I think, more about how to represent different things.
Yeah, maybe. Yeah. They're a bit loosely connected, but that's okay, I think.
That's okay.
Yeah.
And then
The adding haptic emotional stimuli, would that be like if someone, you wanted to share, like, I don't know, someone's heartbeat, and you've got a haptic device that just reflects the other person's heartbeat? Is that what that one's targeted at?
Hi, I think you're talking about the perspective taking one, right?
Yeah.
Yeah. So I've been thinking about it a lot because there's one project, well, there's a lot of projects, but one specific project that is like a VR experience where you are put in the shoes of a Syrian refugee on like a refugee camp. And those projects, I think, are really important for like the perspective taking process of empathy.
Yeah.
But I think we're missing like if we can even take it a step further and we can actually induce into the emotional states of a refugee. You see, if there's like a specific situation where the heartbeat would increase and all that, and haptics are a really good way of doing that as emotional stimuli for those experiences. That's what I was thinking.
Oh yeah.
Yeah. So we did a bit of a study around that where we shared heart rate feedback, and then it's just those 5 controllers were vibrating with the real-time heart rate of the user. So yeah, that's one way, but that's, I mean, if you have the jackets and all, and heart really beats at what your heart is, then it will have a different impact than having it on the hands. I think that's a good research area to look into.
Agree.
There's I think one. Hold on, let me fix that. I think I unlocked something. Okay. And then another big group that was there was measurements and sort of evaluation. So how you can employ physiological measures with reaction delay, how to measure empathy, measuring emotions and cognitive load, internal state detection, AI methods. I mean, this might be here. Easy methods to recognize cognitive load, physiological measures of emotion, evaluating empathy cues for collaboration, measuring the quality of the collaboration, and understanding might be, I can move that to the one on top, but if there are any other experimental techniques, which I assume are study designs and experiments to evaluate it. So I'm adding it here, but if that's not the case, please let me know. And frameworks to evaluate. Could someone clarify what the AI methods for real-time scene reconstruction was? Was that
Oh,
for?
that was mine, and the idea is that if you want to capture and share your environment, it's very hard to do that in real time of your whole environment, but you could potentially use AI to recognize which parts of the environment are being updated or have changed since you last captured it, and then share that, for example.
Okay. Where would that go under collaboration?
Yes, I think so.
Okay.
Also, there's another topic of capturing user environment.
Yeah, so you could also create a new type of content capture if you wanted to.
Yeah, I can do that.
So we can probably group them two together.
Which one?
So yeah, I brought it in.
Oh, okay, sorry. And then we have a couple. Let me actually bring these. Oh, we got everything over. So then I think we have how to minimize encumbrance, empathic tools for enhancing video conferencing, and standardized terms used for empathic computing. Video conferencing could go under collaboration for now.
I guess
Or could go into representing.
Or representing, yeah.
They showed recognizing emotion from Zoom links. A good example of that.
Yeah. And sorry, I missed this one, which is emotions in virtual agents, which is AI and self-learning of human behaviors and how it can respond appropriately, how virtual characters express empathy, and how to represent emotion on avatars and emotional avatars. Is there, like, does it seem like a decent grouping of everything people had in mind? If it does, we can, okay, we can go to the next one. So the next one, because we're not that many people, we can decide to either pick just one of these or just kind of deep dive on a couple, like, or we can actually break into groups if we want to deep dive into like 3 separate things. And we can vote on which ones we want to pick for the 3. Is there a preference?
Well, it looks like we have about 50 minutes left for this activity, and we have about 7, 8 groups here. So if you want, we can just talk about 5 minutes for each of those.
Okay, yeah. Or
I don't know what will be a good way. Then we can cover most of those, or maybe we can ignore the smaller ones. I don't know.
Yeah, we could do that. We can just like talk about it, and I can just keep track of what we're talking about, if that's easier for everyone, and that's what we would prefer. Okay.
Yeah, perhaps we should start with the yeah.
Yeah. Yeah, so we can start. I'll sort of try and keep notes on a separate window so you can still see what's up there while you discuss.
Yeah, okay. So shall we start with the bigger blocks first and then move on to the smaller ones? For example, understanding empathy has quite a few things there. Right. Okay, so yes, we need to probably talk about exactly what we mean by understanding empathy in this context. Right. So here it looks like we have a separate group for measurements. So yeah, so who wrote this understanding the areas of the brain that respond to the emotions and the signals in the brain is giving? So would you like to expand a bit more on that? What are you thinking about?
Yeah, that was my one. Yeah, just having a, I don't know, like a map of the brain. I mean, this probably already exists, but you know, in a real-time situation, and you know, if we can use the BCI, for example, to watch these specific areas whilst experiencing something virtual, and if it's having a real-world equivalent. If the real world equivalent is similar to what's being experienced in VR.
I think I added a few there as well, but I think it was just so I think I added how different types of people perceive empathic cues, and so like based on someone's upbringing or based on their personality types, some people are more sensitive to certain cues more than others. Some cultures are more sensitive to certain types of cues, whether it's non-verbal cues or just like verbal intonations and things like that. And so I think it was just a better understanding across the board of, or I mean, again, this probably exists in sociology or psychology as well, literature as well, but just maybe a more accessible version for everyone in the HCI or the technical side of things to get a sense of like how to use for different groups of people.
Yeah. Yeah, I think you know, now we're all around the world, we're mixing cultures, and you know, there's like, you know, in New Zealand, for example, you know, it was predominantly Māori and English, and we were understood those two groups, but now we're actually, it's a more multicultural society. So now we should understand more of the different culture groups, which I think that's a bit lacking. So I could imagine it's pretty much the same all around the world. We might just be a little bit behind.
Yeah, exactly. Right, and one comment I made, one note is about how does presence affect empathy. So if you're in the same environment, then but the level of presence is different, will that really change how we empathize with one another? Right, so this is something again we can look at using EEGs or other physiological measures. Like if we know, Rory, as you've in your idea, if we know which parts of brain triggers for a particular emotion, and then if we can see in different presence situation where those areas are really getting stimulated or not, or we are getting the same level of brain waves, perhaps that's a way to measure that.
Would this be a presence, you know, on a physical level, or we're talking about the experience of presence in VR?
Experience of presence in VR.
Okay. I think none of the notes, I don't have any notes on that group, but from the understanding the presence, I think understanding the representation of our own avatar could be really interesting, because when Linda presented her paper, she mentioned that we more easily are empathic to people of our demographic. So it'd be really interesting to see if different variations of an avatar, of our own avatar, could actually change the way we interact with other people in VR, I think.
Yeah.
I guess the challenge would be how to measure presence, but some of the same tools for measuring presence could also be used to measure emotion, maybe. So part of understanding empathy would be developing tools to measure empathy.
Yeah. I guess a bit of this understanding empathy and measurement of empathy are quite closely connected. We should bring them closer. So, yeah.
So I think, an emotional reaction to any kind of virtual scene is showing some degree of presence. There's a high correlation between those two.
Yeah, exactly. Okay, so is there anything else? here we have one thing, how do different types of people perceive empathic cues? Will that be in the other block, different user population?
Could be, yeah.
Yeah. Yeah. Okay. Great. And we also have this point here, how to represent emotion in remote people. So would you like to expand on that? What do you mean by this?
Well, that was mine, I think. So if you have a remote collaboration system, and yeah, the other person is represented by an avatar or something like this one, then how can you represent their emotion so that we can understand it? And I guess that gets back to, well, this morning before we had our workshop, there was another workshop on social VR, and they had an interesting paper showing that if you want to recognize the emotions of somebody, it's easier if the person is like a cartoon-like avatar rather than showing lifelike video, because if it's just cartoon, you could have very simple expressions shown on their face, and it's really easy to understand the expressions. Whereas if it's a video like on Zoom, you have to pay more attention to try and pick out their eyes and their mouths and everything, and their subtle face motion.
Exactly.
And I think some people,
some research we've done that, I would say.
Yeah, I think some people, like, I don't know, like me in the morning, for example, I'm happy, but my face might not look that way. So it'd be quite hard to read until I've had, a few cups of coffee, and then I'm perked up. Yeah. So like the cartoons are easier thing to read.
Yeah, that's a good point. But I think here what you have done, Janet, is I think it fits more into the representing empathic cues group. So I think that's good.
Yeah.
Okay.
Since we were talking about understanding, and you said it was close to measurements and evaluation, we can just maybe go there.
Yeah. So is there anything that we have missed? Someone would like to talk about in the other block? If you have missed some point that you'd like to say, anything?
I think something to do with like non-verbal behavior can go a long way as well. So yeah, just the way like if you can represent the whole body, or because I think animals pick up on non-verbal behavior a lot as well. So there's something underlying there, and that might be an interesting way to express emotions.
Okay. Yeah, that sounds correct. So we probably need to add that. Have you added that note there, or?
I don't think it's actually there. So
I'm sort of adding notes based on what we're talking in the below section. I can show you later.
Oh, yeah.
I'm on a separate window.
Okay. Okay. No, that's good. So I can add that. Yeah. So let's move on to the next part, which is measurements and evaluation. Yeah. Yeah, I think this is really a very important thing, as we are all experimental researchers, so we need to measure them properly. But yeah, I guess a tough question is how to measure empathy. Like if we follow on with Alfred Adler's definition of empathy, then yeah, we need to then measure what they're hearing, whether they're feeling like us, or they're hearing what we are hearing in the same way, or perceiving that in the same way. So that's probably a very hard challenge, right? So
yeah, I guess is there any like defined things around empathy, like this shows happiness, this shows sadness, or it's what is that kind of spectrum, or is it too simple? Like is it a 2D map, or like how does it actually look?
Yes. Empathy is too broad of a term, right? Because we can easily evaluate cognitive empathy just to see how well two people understand each other on an emotional level. But then how to study the rest, I think it's the real problem. How do we separate, for example, the emotional contagion, that is like you being affected by someone else's emotional state? How do we separate that phenomenon from some task situation? Like two people collaborating, how do we know that one of them is becoming more stressed because their partner is becoming more stressed, instead of just the task is going really, really awful. And personally, I've been really interested in projects where I can do emotional contagion or like a physiological synchronization between two people to see how the communication would change. And I think we are lacking like what I wrote on the right, that is like a way to pinpoint when someone is trying to do like emotional regulation, like interpersonal emotional regulation, which is a really important part of empathy as well. So having like a framework where we would say this is an empathic exchange, that would be really helpful for evaluation.
Yeah, true. And I guess also depends on the personality trait of a person. Some people are more like emotionally intelligent than others, so how they behave will change or in the situation. So one thing I'm noticing that there are only a few of us are dominating the discussion, so I'd really encourage everybody to speak up. So don't feel that what you're going to say is bad or good. So just contribute and talk. So yeah. Okay. Yes, and so another direction is about the physiological and I guess neurological measurements as well. So is there any particular technology or sensor you think are more appropriate for this? Or
I think it's one of the challenges is to combine multiple sensors together. So in our lab in New Zealand, we've built this open source library called Octopus Sensing that lets you combine input from several physiological sensors and to time tag it, so you can know which happens at the same time. And that's helpful because then you can, if you've got a heart rate sensor and you've got EEG and you want to combine the two together, if you don't have software for doing that, it can be quite challenging to do that. So I think for measurements, part of that is about getting tools. This morning when Anatole was speaking, and one of the big contributions the lab made was developing the Open Vibe software that made it really easy for people to bring EEG input into a wide range of applications and support a whole different types of hardware, which makes it so if we might need some more standardized tools or standardized measures that we can use.
Yeah, that's true. I guess another challenge is with those sensors, because VR, we really move a lot when we perform a certain task, depending on the environment, of course. But that also adds a bit of a noise to those sensors. And then if you're thinking about using those data in real time, then we also need to think about a pipeline, how you can reduce the noise in real time, which makes things a bit more challenging as well. Besides the hardware, I guess the computation afterwards is also a challenging part of that in AR VR environments.
Yeah, I had a study where I was monitoring rate of breath, and but at the same time, my participants had to maintain a level of communication, and then having to chat all the time like that affects your rate of breath. So a way to kind of separate that would be quite useful, and then it'd make the rate of breath measurement more valuable. Because basically, I had to conclude the rate of breath data was not usable because of that.
Oh, because the conversation.
Yeah, because it'd pick it up basically, and you just wouldn't know what was normal or the actual breathing versus them trying to communicate.
Yeah, interesting.
I mean, I guess I could have looked back at I recorded all the conversations. I could have been okay, at this time they were talking, so during that rate of breath data.
The same with the Octopus Sensing library that we've developed, you could have automatically tagged when the microphone is picking up audio or not. And then if you wanted to look at rate of breath, you could have said, okay, well, let's look at just the times when people aren't speaking. And then you could have pulled out the times they're not speaking, and that would have used that to calculate the rate of breath.
Yeah.
think it isn't here, but something that I always think about is like something like empathy or even communication for that matter. Is there are a lot of like invisible aspects from sort of the human perspective? There's a lot that you don't see or that we don't measure or we don't know how they play together. And so for me, it would also be interesting to see both like the quantitative and any form of qualitative measures that we can use to sort of measure the invisible aspects and how reliable they are and how they play together. I don't think we have it here, but yeah, that's just something I think about usually when we design studies, when we're measuring things, especially with respect to communication. But I think it works for empathy. I mean, applies for empathy as well.
Yeah, I think there's a unique interplay between what's happening in the brain and the rest of the physiological space. So like, you know, the brain's going to have an influence on your heart rate, and, you know, you could probably see when both of those are happening.
Yeah. And I guess I guess the conversation part is also very interesting, because when you're talking about a certain thing, but if people who are like me, English as a second language, but talking with people who are native English speakers in a remote situation, so of course the choice of words, the depth of vocabulary we have are quite different. And even if we feel a certain way, but our words may not always express the correct emotion that we are feeling, right? So I guess that's another challenging but interesting aspect to look at, how you know, the depth of language or can affect their, you know, overall emotional experience in a certain situation.
I guess would like some you go for it.
Oh, sorry. I mean, I was just about to say something about the measuring something invisible in the empathy. From the sensing perspective, there's a research project out there done by Chris Harrison in Carnegie Mellon University, where they oversample the signal from the motion sensor on the wristband at the 1000 hertz or something, which usually the sampling rates are like 64 hertz or something. So basically they increased the sampling rate much higher so that they could sense more like detailed motion, which is affected, which is came up from some other like objects you are dealing with in a daily life, for example, like a hairdryer, those things, which comes with very tiny like motion, so that you can your system can understand what object you interact with, or like what are you doing with the objects at the time. So there may be a potential that we can oversample those like a heart rate or those like a GSR or like even EEG at a very high frequency, at a very high like sampling rate, so that we may be able to elicit some kind of new physiological cue out of those like biopotential signals. Or I had to comment on whatever I wrote here, where I mentioned about employing physiological measures with the reaction delay. So basically that's for example, like a GSR, or like there's a person in my lab working on the F-NIRS measurement, which is like a kind of EEG sensing with the light, like IR lighting system that responds to the whatever person perceived. It comes with some like 5 seconds or 10 seconds delay to the response to whatever person perceived. So that probably we need to employ some kind of AI or like a machine learning based system to estimate what's going to be happening in the future by observing the time series like physiological signal to understand empathy. It could be one option we can take for those like a measurement system.
Yeah, that's a good point. So particularly if we are going to adapt the interface based on that detected emotion, then perhaps that adaptation will be delayed quite a bit, right? So based on, in any case, when we experience something, then our physiological signals like they detect a bit later plus other measurements, so the delay will be a bit longer. So Rio, do you think that how much delay is sort of accepted or can cause a problem if it's too?
I mean, it really depending on the application, I guess. So some application don't want to have like a second delay, or some application may be able to deal with like 10 seconds delay, for example. So depending on the application, I guess. But and then also depending on the which like physiological signal you use, for example, like EEG, or more like those like electrical signal response more faster comparing to other sensing where you measure the amount of sweat or like skin conductance, those things, because these cause more this reacts more slower than those electrical signals happening inside the body. So yeah, it really, and then yeah, well, I guess it's always important to consider multiple measures combined together. So there's some research, of course, that when it comes to measuring EEG or ECG, electrocardiogram, in real-time system, people combine those measures with the motion sensor fusion, like IMU, for example, to detect the motion artifacts, to denoise those physiological data out of those motion data, which goes to the sensor. So, well, if we combine multiple sensing methodology so that we can get more accurate signal, which may respond more faster than the pure physiological signal. Yeah, that's what I was thinking. I don't know. Probably other people may have more ideas.
Sure, no, that's a good point. Okay, so we have, I think you have spent some time on this too. Now probably to look into other areas as well.
We can, I think the next biggest would be, I think, representation and collaboration. So we can.
Yeah, but as representing empathic use is the next logical move, because we are now
Yeah.
measured it, now how to represent it.
Yeah.
Right, so yeah. Okay. Yeah, so is there anyone would like to start? So I guess, so adding haptic emotional stimuli to perspective taking into your experience. I guess this is from you, Andrea.
Mm-hmm. Yes.
So yeah, so would you like to, I guess you talked about it already, but yeah, I'd like to start.
Yeah, I talked about it already, but I think I'm really interested now in this idea of physiological synchronization, which is like a forced emotional contagion. And I think especially to take the biofeedback projects a step further into not being just informative, but also working as emotional stimuli between two people. I think that there should be a future direction of empathic computing, and to study actually not just the good things that come from higher empathy, but there are a lot of disadvantages, especially on affective empathy. And I know there's papers on like the psychology of like team building and corporative organization and all that, and there's a lot of disadvantages of empathy, and that's something that we shouldn't shy away from, actually.
Yeah, that's true. So for this haptic emotional stimuli, so do you think like where we provide the haptic feedback can have an impact?
Yeah, actually, I'm now planning an internship where I'm going to be studying that. Actually, I'm going to use like a full body suit, and to see what parts of the body, how we can induce into different emotional states with the different parts of the body, because there are some papers that show that like haptics on the lower back induce into more content feelings, and haptics on the belly induce into anxiety. And yeah, I'm going to be actually studying that soon.
That's interesting. So that's definitely a good study area to measure, and based on what type of emotions they're experiencing, if they're in a, let's say, a fighting simulation where they're shooting each other, or in a collaborative environment where they're helping each other, they may have a different impact, right? Because particularly if you think about shooting, then it's not just heart rate feedback you're receiving, but also the bullets that are hitting you, right? So how do you differentiate between those two haptic feedback, or how do you perceive it, right? So that's an interesting area to really look into. And that's great. Okay. So here is one interesting thing: so understanding users' needs and desires with respect to emotion representation. So I'm not sure who wrote it. So would you like to expand, whoever wrote it? Oh. Okay. So anybody has any idea what to expand from here?
Without knowing like the intention behind the note, it's hard.
Yeah.
But I think there's a lot to be talked about, especially on biofeedback, where we are sharing emotional states between users, understanding how invasive those systems are, and how they actually change like the dynamic between two people.
Yeah, I think that's a good point, because these individual differences also connect to the different user groups that we have another blog there, right? So some people may be more visual thinkers, and they can understand visual information much better than, let's say, haptic information. So, or some kind of stimuli can be too much for some people, right? They have overstimulation than other typical people. So in those cases, of course, that's an interesting area to look into. But how do we do that? That's, I think, an interesting question, that how do we know what kind of feedback people will prefer? All right, so shall we ask them before they start an interface, or will we measure it somehow from their background or their physiological signals in real time, and then change the way we show things? Let's say if we see they're getting overstimulated or agitated, perhaps we stop showing it or show it in a different way. So that also connects to the adaptive interfaces. Or we just do like, we ask them a questionnaire and then fit the interface based on their needs. Another option is probably we let them choose the way they want to see the information. So the system can provide the multiple information, and then they can choose how you want to receive that.
Yeah, it's a tricky question, actually.
Mm-hmm. And which kind of feedback is that users prefer is what I'm very interested in one. And now I'm very interested in developing the virtual character which can change their behavior or tone of voice, or the gestures according to the user's emotions and user's internal estimate. And now I'm very I don't know which feedback is the best to express the understanding of the user's emotion. Yes, so now I'm trying to find it.
Right. No, that's interesting area. I think yeah. So you can adapt it in certain ways. So yeah, it's connected to the other, how to adapt an interface based on the emotion cognitive load, which was my note. Yeah, I guess these 2 points are quite closely connected, and yeah.
I think it also like depends on the application itself. Like for example, like I think my was sort of what cues are important for different types of tasks. So like what cues, it might also be like the goal of the task. When you think of say collaboration, and if it's surgery, the goal is very different from like, let's say if it's a collaboration on a task that's more where you're just sort of like creating something together or something more creative, where for surgery, usually there's a time constraint and there's very little opportunity for something else. So it would also depend on like, at that point, you're prioritizing what's the least intrusive way to get the information across, but versus there's more freedom to sort of explore different aspects of representation with other domains or other applications.
Yeah. Oh, that's great. We're discussing quite a few detailed areas here, which is really great. Okay, so now let's move on. So we have about 18 minutes now left. So maybe shall we look into that multi-user support and collaboration, because those are, I guess, closely connected.
That's a good idea. Yes, that's great. Yeah.
Yeah. Let's have a collaboration maybe.
Yeah.
I think in general with collaboration, again, like I think echoing on my previous point, depends a lot on what the task is, like what is the goal of the collaboration and what are they collaborating on, and whether that's like a virtual task or a physical task, I think defines a lot of the design constraints of like what can be represented, and more importantly, I think what should be represented.
So Mark, I imagine you will have a few points here. So do you?
Yeah, I'm just looking through.
Yeah.
Well, this also relates back to what Riku was just saying, that he's trying to build a character that responds to people's emotion, and so he's trying to think about how to represent emotion on the character's face as well.
Yeah.
So there's some work needs to be done about how visual representation.
So when you're talking about collaboration here in this context of empathic computing, are we just talking about how to enable a collaboration, or how to make that collaboration more empathetic and communicating each other's emotional or cognitive state between the collaborators?
Yeah, I
Well,
understood it.
I'll go for it, Janet, sorry.
Go ahead.
Well, I think it's trying to, it's about how to connect with people, how to enhance the empathy between people. So, yeah.
Yeah, right.
Does a lot of that kind of revolve around, you telling the other person or vice versa how you're feeling? Like, I'm sad today because of what happened some other time, and that's my current state of arousal. And then you're kind of building on the empathy from there.
It can be, but you could also represent it without having to tell them as well. So, for example, if you've got a virtual avatar that could change its representation depending on how you're feeling, then there may be, you don't necessarily have to tell the person that you're feeling, say, happy or sad or whatever, because your avatar is showing them that. And it may be that you don't want to tell them, but your system does anyway. So
yeah,
that's an element of it as well.
Yeah. And is there, say, like, I don't want to delimitate the spectrum of emotions, but you've got your happy and sad kind of thing, and like, would you start from there and be like, okay, I'm either happy or sad, and then you can go down?
Well, that's part of the problem of trying to represent the emotions, because you've got the whole spectrum really. It's just not happy and sad. You've got this arousal valence spectrum, and so then how do you represent that? And then how could that increase the connection between people?
Yeah, I guess one thing here, Mark, about the brain synchronization, So like you presented quite a few times before, that when two people really connect to each other, their brain signals also sort of connect. So same areas of the brain gets triggered. Now, I think that's an interesting area, but do you then think there is another point is about how to measure the quality of the collaboration? So now do you think that is basically measurement of the quality of the collaboration if you see higher brain synchronization?
I think that's a really open area of research. And so, ideally you want to have, in some theory, you want to have some measure on a scale of 0 to 1 or something about how well people are collaborating, but it's really hard to know how to create that measure. So certainly there's some studies that have shown when people have higher brain synchronization, they tend to collaborate together more effectively. But there could be other measures of collaboration, and you use so in face-to-face collaboration, mimicry is really what you use to see if people are connecting with each other. So if you show similar face expressions or body pose as the person you're talking to, that's supposed to be a sign of connection. So there could be several things you could do like that, looking at avatar motion, brain synchronization, even conversational analysis probably would help. If you're interrupting somebody a lot, that means that you're not connecting with them as well as if you're having a natural flow of conversation.
Yeah, I guess another trade-off here is, I mean, not trade-off, but another aspect of it is when let's say we are connecting well with all those measures, but then the actual task that we are performing, the performance is whether it is also better or not, right? Whether the better connection result into better performance in the task. So I guess that's another thing we need to consider. I'm not sure. Is there any study on that, Mark? Are you aware?
I'm not sure actually. Yeah, not that I can recall, but I suspect. Well, there are other people that should be here that could be helping, like people like Linda that's presented earlier. They may have more background knowledge in that space.
Okay, so I guess that's probably another area to look into in this space, whether higher empathy connection creates higher performance. So yeah. Okay.
This is probably where like someone who studies psychology would be really beneficial. Like, is the author Paul Ekman, who's done lots on emotions, and looking at his work could be really valuable.
True. Yeah.
There's a book called Emotions Revealed by Paul Ekman, so it could be something worth having a read of.
Yeah, sure. That's a good thing.
I can paste that in the chat.
Oh yeah, sure.
Great, thank you. Great. Okay, so with that collaboration, perhaps you can move on to the multi-user block, I think. So I guess they're quite closely connected. Yes. So anybody would like to start? Whoever have contributed here.
Well, I wrote the one about controlling multiple avatars, and also wrote the one about multiple people controlling, and single avatar. So Anatole showed that one, but you controlling multiple avatars. You can imagine if so. In social VR, sometimes they create multiple instances of the same environment. For example, in Outspace VR, they can only have 50 people. I think it's 50 in one shared VR environment at once. So if you hold an event that has more than 50, what they'll do is they'll create a second copy of that virtual world and pull the new people onto that one, except for the people that are presenting. So as a presenter, you are presenting an event, and you might be now presenting in 3 or 4 different rooms at the same time, while you've got 50 people in each room watching. So you basically, and what they do right now is they just, your avatar behaves the same in all those rooms, but you could imagine how in the future you might be able to have one person who's controlling multiple avatars that might be doing slightly different things. If there's some AI assisted avatars, And so that might allow you to engage with lots of people at the same time with only paying a small amount of attention to what each avatar is doing. So, you know, with the New Zealand company Soul Machine makes these really intelligent virtual characters. And if that was trained up with your voice and with some of your speech or your background knowledge, then it might be able to carry a little bit of a conversation on with you about you without you even knowing it. And then you coming in when the avatar starts running into trouble and needs the real person to start interacting. So that's just one example of how in the future you might be able to, it might be interesting, your research might be able to how one person can control multiple avatars. It's the same as if sometimes people might be connected to multiple Zoom calls on multiple computers and just listening in and then paying attention to the one where they need to talk to, basically, when it gets to that time, but and the other ones are just listening. So that's what I put down about that.
Yeah, that's a good area.
So when I was doing my study with aerial firefighters, they had to listen to multiple radio channels all at the same time and try and pick up the tone and on different, you know, the aviation side and the ground side and the, you know, the incident management team. And they had to basically get real fine-tuned at doing that. So, yeah. It's quite interesting.
So I wouldn't be surprised if people will start doing that. So as I said already, people will sometimes connect multiple Zoom calls if they're, you know, if they've got a workshop they want to attend and they're supposed to be in a business meeting at the same time, they can swap between two depending on where they need to pay attention. And so it might be the case with social VR where you can have multiple avatars in different locations and not really doing much, just idling and listening to what's happening. And then occasionally you just jump into one avatar body and do something more active and jump back out again and just pay attention. So it's a little bit like your firefighters with being able to listen to lots of audio channels. You'll be now listening across lots of social VR channels and deciding where you want to put your attention, and in the meantime you'll have an intelligent agent that can kind of behave like you.
Yeah, I guess that's that's a good direction. It also connects to the point that the note that I had, how to convey empathy in multi-user platforms. So we're assuming most of the platforms are two people are collaborating, but if there are 10 people and we are collaborating with each other, maybe in a classroom setup or in or similar setups, then what happens? How do we communicate empathy? Whether we communicate it as a group, how the overall as a group, how they're feeling, or for one particular person of interest, right? So yeah, that's another area, I guess, to look into.
I mean, it might depend on the context, but like say with the firefighters, it was more that if the line went quiet and, you know, that gap in communication was an indicator that something was wrong, for example. So there's like kind of hidden cues within communication.
Yeah, true. Okay, so I'm just conscious of time, so probably need to move on to the next thing. So I guess now we are talking about collaboration and multi-use and users. Perhaps we can look into the individual or different user populations, that it has a few. So, yeah, anybody would like to start here? I don't have notes.
Yeah, I mean, like with the kind of animal side, I mean, animals, like, I mean, they can pick up some language, but I think they're looking at you the whole, I know with dogs at least, they're like looking at you and looking at your kind of verbal or non-verbal, I should say, responses, and then they kind of react to that. So I think it's quite an interesting kind of, you know, like we're further along the chain in terms of our brain ability, whereas, you know, you could kind of look to them as more, you know, lower down the chain, but they're using more simple brain functions to process what's going on. So I think it's quite interesting, and it kind of also leads towards the other one I wrote about, you know, people who have had brain damage and that sort of thing. You know, they're relying on the reptilian brain, or that's driving most of their kind of way through their life.
Yeah, yeah, true. Yeah, so I guess you're talking about like dogs in or any other animal in VR, right? And how we as human perceive their state of mind, I guess, or
Yeah.
Yeah. Okay.
Would it also be more of like learning from these or like prioritizing based on like what, since I use sort of simpler cues, we can also pick up from that or learn from that. I think we talked a little bit, like I think my note here was different types of people perceive cues differently, but we've talked about that, I think, before.
Yeah. True.
And then
I guess in overall in this group, we probably need to do multiple studies on each individual group to really understand the mechanism of their, understanding of emotional cues, or how do they really in general interact in VR and collaborate with others, and what cues can be given to them to make the overall experience better, I guess. Right. So, so without studying them, I guess it's very difficult to really say or speculate what's going to happen or what is a better way to do it.
Yeah.
Okay, great. So I guess we are quite close to the time.
Yeah,
So another.
we only have this left as like a main topic. So we can maybe quickly go over that.
Yes. So which one is that?
Emotions in virtual agents.
Emotions in virtual agents. Yes. So yeah, anybody would like to start?
I mean, I'll put the one down about artificial intelligence, and I'm just sort of, I don't know, speculating that AI, because that can have some sort of self-learning behavior that can be applied to understanding human behaviors and emotions, and then using that to drive, like, not avatars, agents or NPCs in the game space. Maybe it leads to a richer, spectrum of emotions, because I mean, we can discuss them all here, but an AI or a computer can go down a much richer path, and we've only got so much ability to do what we need to do.
That's true.
We could probably represent, like, the basic set of emotions, and then we could start going down certain paths, but an AI can just go off and get a supercomputer behind it, and it'll probably figure it out a lot quicker than we do.
Yeah, I think that's so. Yeah, so I guess for that we also need better hardware and more accurate sensing to AI to really process this information more accurately. Like what Anatol has presented today is about 65% accuracy, which is quite good, but it's still not 100%. And now I guess most of his studies where people were really sitting, but if you think about setups where people are really moving, then it is probably even more challenging. But yeah, I think that's the good direction. Yes, and about avatars, so I didn't have any comment here, any notes here. So, but I do remember reading a paper from Patty Mays' group in MIT, where they had, I think it's called Emotional Beast or something, where they represented farts or glow into a particular avatar, and as they were getting more excited, the farts grew longer, and when they're not there, they got shorter. So something like that. But I think that's a way. Is there anybody who'd like to pick on that?
Yeah, I remember that paper. They had the avatars change representation quite significantly depending on the emotions. So you could see like they had fur that would, like you said, get spiky or change color, and based on, I think they use physiological measures to be able to do that.
Yes, and they use GSR, I guess, if I remember correctly.
Yeah, that was interesting.
Yeah.
I guess the challenge with that is that it only helps if the people who are looking at the avatar know what that represents. Like if the character's first starts getting more and more spiky, you might interpret that as the character getting more angry, but somebody else might interpret it as being more happy. So it's one of the challenges. I made a comment there about representing emotion on the avatar. It's one of the challenges with representing emotion, it's only good when other people who's observing it can understand what that representation means. In different cultures, different face expressions mean different things sometimes.
True. Yeah, that's another thing. Great. Yeah, so we have probably last one thing to go through is the content capture. So we have 9 minutes left. So maybe just quickly go through that and then we wrap it up. Okay. So I guess Mark, you had a lot of notes here, right?
A couple of things.
Yes.
Basically, with some of the empathic computing research, you want to be able to capture people's surroundings and share them, so you can enable a remote person to feel like they're like in the same surrounding. But it's technically quite challenging to do that. So if we can build better tools for doing that, that might make it better. So I would love to. Right now, I can use 360 video to remotely share and have somebody remote appear, feel like they're in the same location as me on the video, but the video doesn't convey any geometry information, and you can't actually walk through the video, you can only watch it. So if on the other side we can make 3D geometry, but that takes a long time to scan. So if we can have some tools for rapidly doing that, then also to note what's changing in the environment. Once you've scanned your living room, you don't need to rescan it every second if the only thing's moving are the people or a few objects on the table or something.
Yeah. So do you think the quality of scenes being captured can have an effect on the quality of the overall collaboration or the empathy being communicated between multiple users?
I would assume so, at least. I would assume it would have a very similar effect to some of the studies that have looked at sort of resolution of avatars, or if you recreate a person, so a 3D or a depth capture of a person that's conveyed across. After a certain threshold, the details might not matter, but before that, I think it definitely affects sense of presence, and then sense of presence again affects, I think, how much you connect with the other person. So I would assume there's some form of a threshold there, but I don't know if you know what that is.
Yeah, I think that's a good point. Yes, so that's what I was also thinking about, effect of presence on empathy, the note that I had. So yeah, I think it's quite interesting how all these things are, when we're discussing it, all those areas, but they are kind of, you're finding some connections between them. So they are all quite close, interconnected. Great. So I think, is there any last comment from anyone?
I just shared one project from MIT Media Lab 2011, which is called Focal Space, which is basically a video annotation software where you can put a blur, put a blur and clear part in the video you recorded to record which part of the video you were focusing on, and then also if you select the focus point, you can focusing on the task the person is working on. For example, in the example video, there's two people in the meeting room, where one person is discussing about something with his laptop, and then another person is writing on a big piece of paper to discuss the topic a little bit further. So then in case of this, you can click on the lady in the video so that you can focusing on the paper also, so that you can read what did she write on the paper while we are focusing on only on her conversation. So this kind of methodology, well, this is pretty common nowadays, I guess, in Zoom or those calls where we have virtual blur in the real-time camera input, and then you can focusing on the speaker in the frame. But this kind of methodology can be adapted to those, like a 360 video recording, for example. You can get the point of interest where like all the remote persons are focusing on during like a video tour, for example. Then you can just keep the high resolution video in the one particular spot of the 360 video, and then and other than that can be blurred out, so that you can, for example, you can keep tracking on something important happened in the 360 video while we are minimizing the data size, for example, that could be very important part for the documentation, I guess. Or we can combine multiple different medium. For example, we can combine 360 camera and the depth camera so that we can focus on particular event with a particular sensor which is suitable to record the data or something like that. So we can also, here again, we can do some like a fusion of multiple recording medium to do the content capture. I think this is very good research they have conducted before.
Yeah, no, that's true. Thanks, Rio. Okay, thanks. So I guess we need to wrap up now. We have just 3 minutes left. So first of all, let me thank all of you for attending and participating in this discussion. That's really very insightful. So what we are going to do now is we'll go through all this information that we have captured. We have got this recording. I'm not sure how we are going to get access of it. I guess we need to find out from the peers. And also Janet has taken notes. So what we'll do is we'll now kind of process this and share it on our webpage. And also another thing that we are considering is we write a sort of an opinion piece on this. And I'd really like to invite all of you who are interested to join as an author. Right, so we don't know exactly the timeline of it when we'll do it. Of course, there's a lot of information that we need to go through. But if you're interested, then please send me or anybody in our committee an email that you want to be involved. Then we'll start sharing more information with you. So here is my email. I have just shared in the chat. So yeah, and that's it. Is Mark and Janet, do you have anything to share?
No, just thank you everybody for your participation, and I'm hoping you enjoy the rest of the conference. I noticed that there's a lot of other workshops and tutorials and related themes. So I think tomorrow there's a tutorial at lunchtime around empathy and VR, and there's a number of other workshops and papers being presented through the conference. So please enjoy the conference and try and learn more about this. And then as Arindam was saying, we would love to be able to make a special journal issue. And so those of you interested, if you contact us and we can help put together some papers for an issue, that would be great.
Thanks a lot for this. That was actually quite a fun little exercise, and yeah, I'd be quite keen to help collaborate on the paper. So thanks a lot for the interesting workshop.
Yeah.
I'm not sure, Janet, if you had any words as well.
No, I think the discussions were really nice, and we got into a decent amount of depth for across the board. So that was really nice. So thank you, everyone.
Okay. Great, awesome. Okay, thanks a lot, everyone. So we'll take care.
We'll leave then.
And see you later then. Okay, bye.
Thanks, Arindam. Thanks, Janet.
Bye, everybody.
Bye.
Bye.
Bye.